Respected Professor C.N.R. Rao, Dr. Indumati Rao, who have joined online, the distinguished galaxy of scientists, the esteemed president of this function, respected management members, my dear faculty members, students, friends, and media people. A warm and heartfelt welcome to this momentous occasion as we gather for inauguration of this two-day academic and scientific event. It is an honor to stand before you as we commence the knowledge-enriching gathering and brings together some brightest minds in science, technology, and education. With immense pride, I extend a warm welcome to Bharat Ratna Professor C.N.R. Rao and his wife Dr. Indumati Rao, whose presence, even from the distance, serves as beacon of inspiration for all of us. We are privileged to have with us our esteemed President Shri Krishnamurthy Bhatt, President MP Society, Honnavar, whose leadership continues to guide our institution. Welcome you, sir. Recipient of the Dr. Shanti Swarup Bhatnagar Award is at forefront of cutting-edge chemical research. Mr. N. Jayachandra, coordinator of a special project, former administrative officer at JNCASR, has played a significant role in shaping academic initiatives. We also look forward welcoming Professor Vidyadiraj NS, Dean and a Professor in Technical Science Unit at JNCASR, Professor Srinivas KR, Professor in Engineering Mechanics Unit, who will join us later. Dr. Pradeep Vaishnav, Assistant Professor at International the Center for Material Science, JNCASR, brings invaluable insights into material research. Dr. Shweta Shivprasad, Ramanujam Fellow in Molecular Biology and Scientist Unit JNCSR, is making a remarkable contribution to genetic studies. Dr. Vinayak Pattar, Assistant Coordinator of the Educational Technology Unit at JNCSR, plays a key role in academic advancements. Mr. Ishan is also with us, who is a reputed YouTuber. I welcome him also. I welcome Dr. Shiv Prasad, Dean IIT Dharwad, who will join us tomorrow. Welcome you, sir. Dr. Arun P., visiting scientist at JNCSR, adds wealth of research experience and will be guiding tonight's Stargate program. Lastly, but not least, I extend a special welcome to Mr. Atul Arware, PhD student in New Chemistry Unit at JNCSR, and our esteemed alumni who worked tirelessly in coordinating this event. We take immense pride in welcoming him back to the mother institution. Welcome you, Atul. I express my heartfelt gratitude to our management, faculty members, organizing committee, and student volunteers whose dedication and efforts have made this event possible. Your commitment ensures that SDM Degree College continues to be hub of academic excellence. Dear students, I encourage you to embrace this unique opportunity wholeheartedly. Engage actively, ask questions, and absorb as much knowledge as you can from our distinguished speakers. Events like this are a stepping stone towards a future filled with possibilities. With this brief welcome speech, I would like to give a brief introduction of our college. SDM Degree College, Honnavar, was established in 1964 with the vision of providing education, quality education in arts and science. The institution was founded under the leadership of Sri R.S. Hegde, and its legacy has been carried forward successive president, including Sri M.S. Hegde, Sri R.N. Kamath, and Dr. M.P. Karki, who led the institution for 3 decades until October 2021. The current president, Sri Krishnamurthy Bhatt, continues to guide us with his able leadership and vision. The college has expanded its academic offerings.
Now I request Dr. Manjunath Hegde, the coordinator of STM Star College team, to offer the flowers to our esteemed guests as a token of love and appreciation. We are honored to have Bharat Ratna Professor C.M.R. Rao, founder president of JNCASR, and Dr. Indumati Rao is an educationalist and has been in science education since many decades. She is presently the head of Educational Tech Unit of JNCASR. She has written many books along with Professor Rao and created various multimedia info sources which has become popular. Today, we have both of them joining us virtually. I now request them to address the gathering and bless the occasion.
Good morning, everybody. Welcome to this Wake It Up program. We are conducting 2 days at Honnavar. Honnavar is a good place to meet an audience. It is by the seashore and with a beautiful temple there. This Rejika program is very unique in many ways. Today, this 2-day program, the top scientists and research scholars are participating to take you through an exciting journey of science around us and inculcating the love for science. Now the highlight of this program is the stargazing that has been arranged by the planetarium of Bangalore. Dr. Guru Prasad has arranged to send telescopes and personnel to take you through this exciting journey. And our dear Arun, who is an expert in biology, but his passion is stargazing, he will take you to that. Now I welcome all of you to this two-day program. I wish Professor Rao, myself, and our son Sanjay could have been there to participate in this. Our motto of the programs we conduct is reach out to those who cannot reach into us. And in the same spirit, we have conducted this program. I now request Professor Gio Kulkarni, the President of Jawaharlal Nehru Center for Advanced Scientific Research, to formally inaugurate this. I think he will be joining in person tomorrow, or I'm not so sure what to do, but he will be there to deliver his lecture. Dr. Kulkarni.
Thank you, madam. Am I audible?
Yes, sir. Yes, sir.
Bharatratna Professor Rao, Madam Rao, Sri Krishnamurthy Tipani, President of the NP Society of Honnavar, Dr. D.L. Hebbar, Principal, Dr. Suresh, IPSC Coordinator, Dr. Shivam Shastri, faculty members of the STM College, my colleagues from JNCASR, students. Good morning. I am very happy to inaugurate the outreach program. At the outset, I would like to say that we are very proud to participate, to conduct this program at Honnavar. It all started when Dr. Vijayalakshmi Nayak, former principal, along with Dr. Shastri, visited JNC and met Professor Rao, Madam Rao, and this is exactly when the whole thing got initiated, but that was quite some time ago. Nearly, I guess, maybe 2 years ago or so. For various reasons, we couldn't schedule it on time, but I'm glad that finally it's happening today. And I'm sorry, very, very sorry that I'm not able to participate in person. I'm a person who is greatly interested in the outreach program, but this time I simply couldn't make it, and my apologies for it. I am also proud and happy that I come from that region, Dharwad, and this college is very close to Dharwad, and the college is affiliated to Karnataka University, my alma mater. And the college is very, I know about the college. It has gained a lot of recognition, like A plus in the recent cycle, accreditation cycle, and I think this is the first of that kind in that district. And I'm sure under the leadership of Sri Krishnamurthy Bhatt Shivani, who himself is a noted entrepreneur and philanthropist, the college will go to its new strength. I've already covered in the introduction, the college is very proactive through its various programs, including JAS and JV program, and several research projects. I learned that DST, TPT, VGST, several programs have been taken up, and that is also shown in terms of the students coming back to the mainstream research. We are proud to mention that our POSI student, Mr. Atul, is now presently PhD student. He hails from this place, he comes from this college. And needless to mention, with our president, founder president, Professor C.L. Rao, the center has grown to, JNC has grown to what it is today. It's a premier research institution under the Department of Science and Technology. With around 50 research groups and 400 research scholars, we have many degree programs. And I urge the students who are participating in the outreach program to look at our programs and to take up any one of those programs. Do visit us, spend time with us, get exposed to what we are doing. And if some of you are interested, you could be joining for research with us. The campus looks a bit deserted today, and as you can see, half of the faculty or almost half the faculty at Honnavar. That's the kind of efforts we give to our outreach programs. And Honnavar is again a very special occasion for us to do this program. Our three deans are around and should be around to kindly accept and place them in a place where students can go to see and interact. So with these words again, I'm very happy to inaugurate and I'm sorry again, and I should be visiting the college very soon. And meanwhile, I wish you all the best. And I'm sure this workshop and program should ignite excitement among students to pursue scientific research. Thank you very much. Yeah, and maybe some children in that. Thank you.
We are celebrating International Women's Day, and as a mom, we are beginning this program with a women scientist. It is our pleasure.
Thank you very much for the introduction. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಐ ಆಮ್ ವೆರಿ ಹ್ಯಾಪಿ ಟು ಬಿ ಹಿಯರ್. ಇದು ನನ್ನ ಫಸ್ಟ್ ಟೈಮ್ ಈ ಥರ ಔಟ್ರೀಚ್ ಇವೆಂಟಲ್ಲಿ ಪಾರ್ಟಿಸಿಪೇಟ್ ಮಾಡ್ತಾ ಇರೋದು. ಐ ಆಮ್ ವೆರಿ ಗ್ರೇಟ್ಫುಲ್ ಟು SDM ಡಿಗ್ರಿ ಕಾಲೇಜ್, ಡಾಕ್ಟರ್ ಹೆಬ್ಬಾರ್, ಡಾಕ್ಟರ್ ಹೆಗ್ಡೆ, ಮಿಸ್ಟರ್ ಭಟ್, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಐ ಆಮ್ ವೆರಿ ಹ್ಯಾಪಿ ಟು ಬಿ ಹಿಯರ್ ಟುಡೇ. Thank you for inviting me here. I'm very thankful to JNCASR, Professor C.N.R. Rao, Mrs. Rao, our President, Mr. Jai Chandra, Mr. Vinayak, and of course Atul, who has bridged and coordinated this entire event. Thank you very much for this opportunity. So, basically I am a virologist, so viruses mele kelsa madodu. But ivattu I will speak broadly about microorganisms. ಸೊ ಮೈಕ್ರೋ ಆರ್ಗಾನಿಸಮ್ಸ್ ಅಂತ ಎಲ್ಲ ಕೇಳಿರ್ಬೋದಲ್ವಾ ನೀವು? ಕೆನಾಟ್ ಬಿ ಸೀನ್ ಬೈ ದ ನೇಕೆಡ್ ಐ ಅಲ್ವಾ? ಏನಾರು ಒಂದು ಬೇಕು ನಮಗೆ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್, ಮೈಕ್ರೋಸ್ಕೋಪ್, ಅದ್ರ ಕೆಳಗಾರ ನೋಡಿದ್ರೆ ಮಾತ್ರ ಕಾಣಿಸೋದು. ಮೈಕ್ರೋಬ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಗುಡ್ ಆರ್ ಬ್ಯಾಡ್. ಸೊ ಸಮ್ ಮೈಕ್ರೋಬ್ಸ್ ಆರ್ ಗುಡ್ ಫಾರ್ ಅಸ್, ಸಮ್ ಮೈಕ್ರೋಬ್ಸ್ ಆರ್ ನಾಟ್. ಸೊ ಇವತ್ತು ಲೆಟ್ ಅಸ್ ಲುಕ್ ಅಟ್ ಫ್ಯೂ ಆಫ್ ದ ಮೈಕ್ರೋಬ್ಸ್ ದಟ್ ವಿ ನೋ. ಸೊ ನಿಮಗೆ ಯಾವಾಗ ಬೇಕಾದ್ರೂ ಏನು ಪ್ರಶ್ನೆಗಳು ಬೇಕಾದ್ರೂ ಕೇಳಿ, ಫೀಲ್ ಫ್ರೀ ಟು ಇಂಟರಪ್ಟ್. ಇವಾಗ ನಾನು ಕ್ವೆಶನ್ ಕೇಳ್ತೀನಿ, ನೀವು ಆನ್ಸರ್ ಹೇಳ್ಬೇಕು ಫಸ್ಟ್, ಆಮೇಲೆ ನೀವು ಕ್ವೆಶನ್ ಕೇಳಿ ನಾನು ಆನ್ಸರ್ ಹೇಳ್ತೀನಿ. ಇನ್ಫ್ಲಮೇಷನ್ ಅಂದ್ರೆ ಏನು? ವಾಟ್ ಆರ್ ದ ಮೇನ್ ಮೀಡಿಯೇಟರ್ಸ್ ಆಫ್ ಇನ್ಫ್ಲಮೇಷನ್? ಇಮ್ಯೂನ್ ಸೆಲ್ಸ್ ಅಟ್ಯಾಕ್ ಮಾಡಿ when they are trying to resolve an infection, ಇನ್ಫ್ಲಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊಳ್ಳೆ ಕಚ್ಚಿದಾಗ ಆಗುತ್ತಲ್ಲ, ಸ್ಕ್ರಾಚ್ ಮಾಡ್ಕೊಳ್ತಾನೆ ಇರ್ತೀವಿ, ದಪ್ಪಕ್ಕೆ ರೆಡ್ ಆಗಿ ಊದ್ಕೊಳತ್ತಲ್ಲ, ಈವನ್ ದಾಟ್ ಇಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಆಫ್ ಇನ್ಫ್ಲಮೇಷನ್. ಸೊ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಲಾಟ್ ಆಫ್ ಇಮ್ಯೂನ್ ಸೆಲ್ಸ್ ಕಮ್ ದೇರ್ ಟ್ರೈಂಗ್ ಟು ಕ್ಲಿಯರ್ ದ ಫಾರಿನ್ ಪ್ಯಾಥೋಜನ್. ಸೊ ಅವಾಗ ಇನ್ಫ್ಲಮೇಷನ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ನಮ್ಮಲ್ಲಿರೋ ಇಮ್ಯೂನ್ ಸೆಲ್ಸ್ ಎಲ್ಲ ಬಂದು ಅಟ್ಯಾಕ್ ಮಾಡ್ತಾ ಇದೆ, ದೇ ಆರ್ ಅಟ್ಯಾಕಿಂಗ್ ದ ಪ್ಯಾಥೋಜನ್ ಅಂಡ್ ಆಸ್ ಅ ರಿಸಲ್ಟ್ ಒಂಥರ ಇನ್ಫ್ಲೇಮ್ ಆಗುತ್ತೆ ಟಿಶ್ಯೂ. ಸೊ ಕ್ರಾನಿಕ್ ಆಗಿ ಒಂಥರ ಇನ್ಫ್ಲಮೇಷನ್ ಆಗ್ತಾನೆ ಇದ್ರೆ ಇಟ್ ಇಸ್ ನಾಟ್ ಗುಡ್ ಫಾರ್ ಅಸ್. ಇವಾಗ ಸೊಳ್ಳೆ ಕಚ್ಚಿರೋದು ಗುಳ್ಳೆ ಆಗುತ್ತೆ ಅಲ್ವಾ, ಆಮೇಲೆ ಹೋಗುತ್ತೆ, ಅದು ಯಾವಾಗ್ಲೂ ಇರುತ್ತಾ, ಹೊಟ್ಟೋಗುತ್ತೆ ಅಲ್ವಾ, ರಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಸೊ ಕ್ರಾನಿಕ್ ಆಗಿ ಇನ್ಫ್ಲಮೇಷನ್ ಆಗೇ ಇದ್ರೆ ದಟ್ ಇಸ್ ನಾಟ್ ಗುಡ್. ಸೊ ಕ್ರಾನಿಕ್ ಇನ್ಫ್ಲಮೇಷನ್ ಆಗಬಾರ್ದು. ನಮ್ಮ ಬಾಡಿ ಯಾವುದೇ ಟಿಶ್ಯೂ ಯಾವಾಗ್ಲೂ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಇನ್ಫ್ಲಮೇಷನ್ ಆಗಬಾರ್ದು. ಇಟ್ ಇಸ್ ನಾಟ್ ಗುಡ್ ಫಾರ್ ಅಸ್. ಸೊ ಈ ಶಾರ್ಟ್ ಚೈನ್ ಫ್ಯಾಟಿ ಆಸಿಡ್ಸ್, ದೇ ಹ್ಯಾವ್ ಆಂಟಿ ಇನ್ಫ್ಲಮೇಟರಿ ಪ್ರಾಪರ್ಟೀಸ್ that keep our guts very healthy. Inflammation ಆಗದೆ ಇದ್ದಾಗ ನೋಡ್ಕೊಂಡ್ರೆ it keeps the gut very healthy. ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಸಾಕಪ್ಪ ತಿಂದಿದ್ದು ಅಂತ ಒಂದು ಸಿಗ್ನಲ್ ಮಾಡುತ್ತೆ. ಆಲ್ಬಲೆನ್ಸ್ ಅಂತ ಅದರಲ್ಲಿ ಇದ್ದಿದ್ದ ವೈರಸ್ ಇಟ್ ಜಂಪ್ ವಿತ್ ಹ್ಯೂಮನ್ಸ್. ಸೊ ಜಂಪಿಂಗ್ ಆಗುತ್ತೆ. ಹ್ಯೂಮನ್ಸ್ ಜಂಪ್ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಏನೋ ಒಂದು ಎನ್ಕೌಂಟರ್ ಇರ್ಬೇಕಲ್ವಾ? ಸೊ ಯಾವ ತರ ಎನ್ಕೌಂಟರ್ ಇರ್ಬೋದು? It can be by touching animals, it can be by hunting, our consumption of meat, agriculture, animal domestication, deforestation, ಇವಾಗ ಡಿಫಾರೆಸ್ಟೇಷನ್ ಆದಾಗ ಈ ಆನಿಮಲ್ಸ್ ಇನ್ಸೆಕ್ಟ್ಸ್ ಎಲ್ಲ ಆಚೆ ಬಂದ್ಬಿಡ್ತಲ್ಲ ಫಾರೆಸ್ಟ್ ಇಂದ ಆಚೆ ಬರುತ್ತೆ ಸೊ ದೇರ್ ಇಸ್ ಅ ಹೈ ಪಾಸಿಬಿಲಿಟಿ ದಟ್ ದ ವೈರಸಸ್ ದಟ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದಟ್ ಕ್ಯಾನ್ ಕಮ್ ಟು ಅಸ್ ಸೊ ದೇರ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಅನ್ ಎನ್ಕೌಂಟರ್ ಅಂಡ್ ದೆನ್ ಆ ವೈರಸ್ ನಮಗೆ ಜಂಪ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಶುಡ್ ಬಿ ಏಬಲ್ ಟು ರೆಪ್ಲಿಕೇಟ್ ಇನ್ ಅಸ್ ಎಲ್ಲಾ ವೈರಸ್ ಎಲ್ಲಾ ಕಡೆನೂ ಗ್ರೋ ಆಗಕ್ಕೆ ಆಗಲ್ಲ ಸ್ವಲ್ಪ ವೈರಸ್ ಬರೀ ಆನಿಮಲ್ಸ್ ಮಾತ್ರ ಗ್ರೋ ಆಗುತ್ತೆ ಸ್ವಲ್ಪ ವೈರಸ್ ಇನ್ಸೆಕ್ಟ್ಸ್ ಮಾತ್ರ ಗ್ರೋ ಆಗುತ್ತೆ ಸ್ವಲ್ಪ ವೈರಸ್ ಗಳು ಹ್ಯೂಮನ್ ಸೆಲ್ಸ್ ಮಾತ್ರ ಗ್ರೋ ಆಗುತ್ತೆ ಸೊ ಆ ತರ it is not easy for a virus to jump and cause a pandemic so adana spill over anta ಹೇಳ್ತೀವಿ so there are many barriers for a spillover to happen covid was one such the SARS-CoV-2 virus was one such virus which had all the right conditions to infect so that's how it made a transition from animals to humans so bleach is something that can kill viruses so ಅದಕ್ಕೆ ನಾವು ಲ್ಯಾಬ್ ಅಲ್ಲೂ we use bleach to disinfect but otherwise if it doesn't come into contact with any bleach
The first question is actually a sports question, okay? I'm reading it out, okay, at the age of 10, okay, listen to the question carefully. There is some person called Richard Stokes, okay? This guy at the age of 10, he went with his father to watch the 4th Ashes test in England in 1956. Something happened in that match, okay? That only those who were there in the stadium saw live because that time there was no broadcast, okay? Something happened. 43 years later, okay, he had come to India, this Richard Stokes, and in 1999 he said, I will go to Delhi and I will watch this India-Pakistan match live. That incident that had happened 43 years earlier happened again in 1999. And it has happened, after that it has happened only once, okay, so totally 3 times. What was this unique incident that this guy got to see live twice and it has happened 3 times totally? I'll give you a hint, one of these events was by an Indian is involved in one of these unique achievements in cricket. What did he say? What did he say?
10 wicket haul by a single player.
Beautiful answer, that is the answer. One bowler taking all 10 wickets in an innings and very good Pradyum, you gave it already.
Google it or what?
Did you Google? Very good answer.
How do you know?
So the quote goes as this: I was in a council meeting when then Prime Minister Rajiv Gandhi, when Manishankar Iyer called me and said a dash was to be set up for dash. The original idea was not to have an independent organization, but rather a sister organization, something that can assist a larger entity that can complement the larger organization's work. Most of the ministers preferred Pune for its establishment, but only Rajiv Gandhi supported me when I suggested dash. What were those dash and dash?
So the question is very simple. Somebody is talking, okay? Somebody is talking about something. What they are saying is that they were in a council meeting with, Rajiv Gandhi, the Prime Minister at that time, and Manishankar Iyer, one of the ministers, called this person who is speaking and said that, we want to establish something, and every minister in the cabinet said we should establish this in Pune. Only Rajiv Gandhi said, no, you should establish this in Bangalore itself. Who is talking and what are they talking about? Yes, somebody. Who is talking? That's a correct answer, but who is speaking? Come on, okay. Is that half? Okay, we'll give you half a pen. We'll give you cap. Okay, you can give.
But if
who is speaking? Yes. Professor C.N.R. Rao speaking about JNCASR. Helix here.
This is the structure of starch. The starch is basically a polysaccharide. You see there are 2 components of starch. One is called amylose and other one is amylopectin. Now for the formation of complex, we saw the color, blue color. I'll demonstrate that later. The picture on the left, amylose is the key. What it does is, it is a linear chain of, there are monomers. Are you aware of monomers of starch? It is a cyclic structure, right? and the several cycles join and form a chain. And in biological system, if you know aware of the DNA, RNA, they never became a straight chain. They either form a kind of a ternary structure or they form helix and so on. So this is one of the helix example. Now this helix is the schematically shown here. Helix has a cavity. It's just like spring we use in pen or the pen with refill. You use a small spring. Exactly look like this in the small scale, at the atomic scale. Now, because this is a helix, there is a cavity. In that cavity, iodine goes inside, and then the charge transfer happens. So you see a color. Okay. So one of the experiments that we do is called iodine cloak experiment. So you can track this complex formation by monitoring iodine concentration in terms of time. So let me start that. I have 5 solutions. I'm making different with different concentration of iodine. So what I'm doing is I'll make 200 in each beaker. There will be 200 milliliter solution at the end of the experiment, and the calculation is such that I have potassium. The very first, you see that the Ki is a source of iodide, Ki, okay, potassium iodide. When that reacts with sulfuric acid and hydrogen peroxide, it gives you molecular iodine. That's the, you are aware of iodine, right? This is a volatile gaseous stuff. So in this whole thing, the first reaction is rate determining step. Are you aware of what is rate determining step in chemical kinetics? Yeah, please say, what is that? Louder. You can stand up and say, that will be so nice. The step that is slower is rate determining step, right? It's always the slower one is determining the rate. So in these 2 reactions, first one is rate determining step, and in that step iodine forms. So now what I do is I have a table there. It's also on the computer, but so he is filling water in that. I made table on the screen. You can see. And what I am doing is I am adding sulfuric acid. Okay. Moles of protons you get out of 1 mole of sulfuric acid if you make a aqueous solution. Right. Yeah, please come forward. Very nice. Because they are not directly touching the chemicals. Okay. What they have is a dropper. In this dropper, we'll suck 2 milliliter of the hydrogen peroxide. That's the last reagent we are adding. Moment we add hydrogen peroxide, there will be iodine forming. And when iodine forms, there's already sodium dithionate is there that will consume iodine. So as long as iodine is consumed by sodium dithionate, you won't see color because iodine I2 is not available for color to produce.
On the count of 3. 3, 2, 1. Stir.
You have not poured. You have
Press ಮಾಡಿ.
It has to be emptied. Now let's start it.
Stir ಮಾಡಿ.
Yeah, you can leave it now. Yeah.
Okay, you can leave it now.
Yeah.
Start the time, count ಮಾಡಿ.
Press it.
ಯಾವಾಗಲೂ ನಾವೇನ್ರೆ ಡ್ರಾಪ್ ಕಾಸ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ನೋಡ್ಕೊಳ್ಳಿ. ಬಿಡಿ ಅದು ಮುಗಿತದ ಆಟ. ಬಿಡಿ ಫಿನಿಶ್. ಯಾವಾಗಲೂ ಡ್ರಾಪ್ ಕಾಸ್ಟ್ ಮಾಡ್ಬೇಕಂದ್ರೆ ಅದ್ರ ಒಳಗಡೆ ಮುಗಿಸ್ಬಿಟ್ಟು ಡ್ರಾಪ್ ಕಾಸ್ಟ್ ಮಾಡ್ಬಿಡಿ ದಯವಿಟ್ಟು. You have to drop us like this. See, you are getting my point. There is a way to do that.
So you see the first one.
See the color.
Very first one now. One of you should note down. You can come in the front. There is a corridor here.
See here. The third one is changing.
You see that. I am just adding 1 drop. It's a commercially available solution, but you can also make it. This dye basically is a solid, but you can make it in ethanol. So one drop I am adding, it is a blue. So expect the solution color to be blue. Okay. Now this color is just because dye was originally blue. Still we don't believe that gluconic acid has formed. Okay. But let's see what happens next, and then only we can conclude that it is happening.
Observe carefully.
So on the screen I have written, if there is a gluconic acid formed, it will reduce methylene blue. Here I have drawn that picture. Okay. So
You
now,
can see that bottle.
what was the color before? You could see that, right? Maybe the background may not be able to see, so I'll bring it there. So now you see that once reduction happens, this is what is not anymore blue, right? But you can do one thing. You can make it blue again. Okay. So what I did, you see the first step, that's the reduction. Okay. That was done by gluconic acid. Now I reacted it back with oxygen, because this bottle also has oxygen, right? Is water in tap water or distilled water, is there oxygen? Plenty of oxygen there, right? That's how the aquatic animals survive, right? So I took distilled water which has oxygen. Also there is an empty area which has oxygen. This oxygen reacts with this thing and oxidizes. Are you aware of redox reaction? Reactions which have reduction and oxidation both. So this is that kind of reaction. For reduction you need gluconic acid. For oxidation you need oxygen. So now what I am doing again. Reaction with oxygen is not easy. So I have to check it well. So it will be careful. Okay. Now you leave it. You leave it again. This top reaction will proceed. Are you able to see color? Maybe that light problem.
Now it is turning
It's
into
gone.
the colorless.
It was blue, is not anymore blue, right? So this reversible. I drawn two arrows forward and backward. That is the indicator of what? It is a reversible reaction, right? Light green, thinning green is going. Oh wow! See what is happening. Are you able to see red from there? Okay, but wait, it is not the end of the story. Now what you see? Yellow. Yellow. So it was originally indigo. Once you dump in this one, gluconic acid become green, then become red, then become yellow. And it will stay yellow like this.
Why that?
Yes, that is the key. Okay, I'll tell there. Now, if I shake it slowly, what is the color? Red. It will go to yellow. But if I shake it too fast, it become green. Okay. Now let's talk about the chemistry that it has.
Those who has not seen the hydrogen and oxygen coming out from this electrolysis of water, I'll explain what is happening. So we have a battery where positive and negative terminal is there. So the electrode which is connected to the positive terminal, which will lead to oxidation of water. So we will be getting pure oxygen gas. The bubbles are coming out. Other side, which is connected to negative terminal of the battery, will lead to reduction of water to pure hydrogen. So there also you are getting bubbles. But the quantity of these bubbles would be 1:2 ratio. Because H2O will lead to H2 plus half O2. Hai half O2 will not consider this. 2 molecules of water will give 2 molecules of hydrogen, 1 molecule of oxygen. So one side more bubbles, one side less bubbles. This is what happening in the system.
I heartily welcome Professor Supi J. George and I request Dr. Nandini Shetty to offer a flower as a token of respect.
Thank you. Good afternoon, all. Okay, so thank you for the kind introduction, but the best introduction would be, I'm very proud to be here because one of your alumni are a wonderful student in our department, so Adul Avare. So he is a brilliant student and a very dynamic student. So very happy that he joined us as a post student earlier, but very happy to have him back as our PhD student. So that's the best introduction I would love to have. So alumnus comes from our department. Okay, so thank you for the kind introduction, and very happy to be here. So thank you everyone for the kind invitation. So I know it's challenging for two reasons. One is you had a wonderful lunch. Many of you will have a tendency to do some meditation, but I'll try my best to take all of you with me. So be with me. So I'll make it simple and probably try to be interactive. And second thing is, I need probably Vinayak's help because I don't know Kannada. So if anything is there, I want Vinayak to pitch in. Okay. So thank you. So we'll just go to a kind of new. So also I just want to mention new chemistry unit. I'll have a couple of slides towards the end of my talk to tell what is this new chemistry, so that I will keep it towards the end of my talk. So I just want to introduce a new field of chemistry, which is there for like 3 decades or 4 decades. So that is called supramolecular chemistry. So just to start with, how many of you know supramolecular chemistry? Not here, not from here, not from you also, because the same slides he's going to see. So he attended my class last year. So no one. So that's, how many of you know what is a molecule? All of you, right? Raise the hand. Molecule. Right? So the supramolecular chemistry is defined. So just be interactive, okay? So raise the hand. So chemistry, yeah. Can you hear me now? Okay. Did you hear what I said before? Okay. So the supramolecular chemistry is the chemistry beyond the molecule. Okay. So don't worry. I'm sure that many of you would have not heard about it. But I will introduce very briefly. So I will try to explain it with some nice videos and all those things so that you don't get into this meditation. Okay. So you see nice video here. It's an animation. So many things are happening, highly dynamic, lot of complex things are happening. Do you know what is this? What is the video all about? It's an animation. It's not a real video. But then what is that picture? What is that video is all about? Sorry? Louder. Host and guest is the definition of supramolecular chemistry, because this video is just made by some people in Harvard University to give you a feel of what is our cell. Okay, so this is an animation of the various processes which is happening inside our cell. All of us cells, all of you know what is about cell, right? So this is a video just to say this. These are microtubulin proteins which is forming, it is there everywhere in our cytoskeleton. So you see that it forms, disassembles and everything. That is very important for the cell motility, is cell division and everything. So you see that it is highly complicated process. All of you agree? There are many things happening, so it's highly dynamic process. So the point is that when you look into the cell very closely, there are two things. So I'm just trying to tell how supramolecular chemistry started. The field has started like probably 3 decades. And this is a field which is highly inspired by nature or biological systems. Can we mimic something which is in nature, a cell for example? So if I give you all the components of a cell to your laboratory, like Pradap did a wonderful experiment, I ask you to combine all of them and make a cell. I will give you all ingredients. Will it be possible? What do you think? Will it be possible? I want it to be interactive. Will it be possible? It's not possible, because if you look into so this is a simple graph. Just want to show. It's a very simple graph. The x-axis is a size, okay, and y-axis I am talking about something, a measure of complexity. Let it be anything, okay? It's a measure of the complexity. And you know that this is a atom. This is a right side is what? Galaxy, okay? And I put it cell here. And you see, sir, that if you look into the complexity, doesn't matter, it's very small. This is considered as one of the most complex structure one can have. Okay, so even if I give all the ingredients of a cell and ask you to make it, it may not be possible. So cell is so smart, it does a lot of functions. So so the supramolecular chemistry is a field which just started by saying a group of chemists started thinking, can you make something synthetically a complex structure like this? Okay, so how they form DNA? What is the interactions between the two strands? Be louder. It's hydrogen bonding. So what is this hydrogen bonding? It's very strong interaction or weak interaction? Weak interaction. Very weak interactions. Okay. So you see that you recognize what is this? It's like our membrane, cell membrane. What is cell membrane? It's a bilayer of lipids kind of systems, right? So you look into most of the structures in biology, they are not a single molecule. Okay, what is it? It's an assembly of molecule. It's an ensemble of molecule. Can we mimic something in biology in natural world? So that was the beginning of the supramolecular chemistry, and these three people got Nobel Prize, and most of them are still active and very simple contribution. Something which is very simple, because anything which can the fuel here, it is a kind of electrochemical fuel. It's a light fuel. So what they have done is they have invited a competition from. So this is a nice YouTube video. You can go this. So there are 7 teams participated in this. So they came with 7 different molecules which can do such dynamics, such faster things. And then what they have done is they created a track for each molecule, and then they started moving and they announced who is the winner. And you know what is the size of this track? Just a 1 micrometer. And because it's a molecular nano car, but and even the guys who won, to cover this kind of 24 hours, it took to cover that kind of 1,000 nanometer. So it's one of the fastest car, you know, right? Right? So it's one of the slowest car, but I'm saying, so this is a kind of creativity. At least there is a track is given to you, molecule could move from one side to the other side.
How supramolecular chemistry contributes on artificial life? How can supramolecular chemistry?
Artificial life, yeah. So as I mentioned at the beginning, I know that this question, whenever I make a comparison with cell, people always ask me. But then, as I mentioned at the beginning, we are not into the functions, but something which people do towards in terms of biomaterials and everything. So there are groups which work on regenerative medicines, so skins which are or self-healing and so on. So, but that is not towards the life yet. Can you see that these are all value on additions to a material? Okay, so supramolecular chemistry right now stands there. But if you look into Europe and everything, one of the active calls, I mean, for research we have to submit grants and then get funding and do. So one of the biggest, one of the most common title, if you look into it, most of the Europes is towards synthetic life. Okay, and that is, most of them are based on supramolecular systems. And one of the things which I did not show, I did not get time, is one of the important direction that way is to, because all these materials I showed is at equilibrium. So, okay, but if you look into synthetic cell and everything, this is far away from equilibrium. This is, we call it as a non-equilibrium. Okay, and there are also a lot of effort going on to make materials which is away from equilibrium and everything. So that is little bit advanced, that's why I did not touch on it. So that is one direction people are going, but artificial life is still far, far away.
Yeah, it's a good question, and yeah, come here. You ask the question.
You can.
Thank you. It's a new form of carbon, the nanocarbon. Okay?
They are quite stable. All stabilized by hydrogen bond, but I am saying hydrogen bond energies are small. So what is the why these are stable? No, I'm saying, see, if you are alone, so just take an example. If you are alone, you are very weak, right? But you are all put sitting together, you are strong or weak? Strong. So it's like something called in, so that is just like that. So in scientific world, we call it as a cooperativity, right? Alone one, you are weak, but if you act together, it's not an additive, it's not 1 + 1 is 2, it is always greater. Okay?
Thank you. Can you hear me? The last bench. Can you hear me? Last bench. And you raise your hand if you hear me. Very good, yeah. So, it's a bit tough time only. I think Subi was successful in holding all of you awake. So, it's a nice. So, today I will be talking on nanomaterials and their multifaceted applications. I was planning to talk nanomaterials and catalysis, but since considering the audience thing, so I will little broaden this area. And I come from Jawaharlal Nehru Center for Advanced Scientific Research. How many of you visited Bangalore? How many of you visited Bangalore? Only very, okay. In this number, I cannot expect any many visited JNCASR. Give a brief overview about JNCASR. And this institute was established in 1989. This was established to commemorate the birth centenary of Pandit Jawaharlal Nehru, the first Prime Minister of India. Under the guidance of Professor C.N.R. Rao, Bharat Ratna Professor C.N.R. Rao, and he is he is one of the important scientific stalwart in India, you all know. And he is still coming and interacting with the students, and he not only knows the science but also the scientist. And you can, whenever you are visiting JNCASR, you can see this kind of scenes. This what happened? Yeah. So about JNCASR, this is a boundaryless science with focus on material science, biology, engineering. Of course, material science engineering also comes into that, materials engineering. Strong interaction with the industry, national and international labs. So that means one side 20 by 20, 400 micrometer square the area. It's a closed cube. If I have to look at the surface area of this cube, you can see there are 6 sides, each side 400 micrometer square area. So there are 8 cubes. You will be having 4,800 micrometer square area. Is that clear? Same cube, volume is same. This is 8,000 micrometer cube. In this case also 8,000 micrometer cube. What I did, I only just cut into small pieces of 8 cubes of same size, same volume, 8,000 micrometer, only one block. I'm just cutting into 1,000 tiny cells. And surface area goes from 2,400 micrometer square to 24,000 micrometer square. Imagine if I have to go to nanometer. So it will be even, I will be increasing the 10-fold or 100-fold increase. At least 10-fold increase I can see easily. This is very much important, particularly when you see that
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good morning to all of you. Because there are a lot of girls here, I also want to express Happy Women's Day today. What I felt is I should go and shake hand with every woman here, but which is difficult. So what I'll do is I'll just hand over this to the wonderful lady who introduced me, okay, as a representative of all the women here. Madam, Happy Women's Day. Happy Women's Day. Yeah, very nice. Very delighted to be here. And again, of course, I gave the thing to her. Now let me also connect with all of you. The high five from here. Okay, all of you give a high five. Yeah, very nice. Yeah. Hey, give it here. Don't hesitate. Come on. Yeah, come on. Okay, wonderful. Okay, so, before that, I have to ask one more question before I start. Okay, ಎಷ್ಟು ಜನಕ್ಕೆ ನಿಮ್ಮಲ್ಲಿ ಸೊಕ್ಕಿದೆ ಕೈ ಎತ್ತಿರಿ. ಸೊಕ್ಕು ಯಾರ್ಯಾರಿಗಿದೆ ಕೈ ಎತ್ತಿರಿ ನೋಡೋಣ. ಒಂದು ಎರಡು, ಓಕೆ, 5, 8, 10, 15, ಓಕೆ, ಸುಮಾರು ಒಂದು 20 ಜನಕ್ಕೆ ಸೊಕ್ಕಿದೆ. ಎಷ್ಟು ಜನಕ್ಕೆ ನಾಚಿಕೆ ಇದೆ ಕೈ ಎತ್ತಿರಿ ನೋಡೋಣ. ನಾಚಿಕೆ ಎಷ್ಟು ಜನಕ್ಕಿದೆ? 1, 2, 3, 4, 5, 6, ಒಂದು 10, 12 ಜನಕ್ಕಿದೆ. ಓಕೆ, ಸೊ ಒಂದು ನಿಮಿಷ, ಯಾರು ನೀವು ಕೈ ಎತ್ತಿದಿರಲ್ಲ ನಿಮಗೆ ಸೊಕ್ಕು ಇಲ್ಲ ನಾಚಿಕೆನೂ ಇಲ್ಲ, ಅದಕ್ಕೆ ಕೈ ಎತ್ತಿದ್ರಿ. ಯಾರು ಕೈ ಎತ್ತಿಲ್ಲಲ್ಲ, ಸೊಕ್ಕು ನಾಚಿಕೆ ಎರಡೂ ಇದೆ, ಅದಕ್ಕೆ ಕೈ ಎತ್ತಿಲ್ಲ. ಯಾಕೆ ನೀವು ಏನು ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ನೋಡಿದ್ರಿ ಅಂದರೆ ಯಾರು ಮೇಸ್ಟ್ರುಗಳು ಕೈ ಎತ್ತಲಿಲ್ಲ ಎಕ್ಸೆಪ್ಟ್ ಯುವರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅಲ್ವಾ. ಸೊ ದಟ್ ಶೋಸ್ ಹಿ ಈಸ್ ಅ ವಂಡರ್ಫುಲ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್. ಸೊ ಫಾರ್ ಯು ಆಲ್ ಟು ಸಕ್ಸೀಡ್, ಫಾರ್ ಆಲ್ ಆಫ್ ಯು ಟು ಸಕ್ಸೀಡ್ ಇನ್ ಲೈಫ್, ಸೊಕ್ಕು ನಾಚಿಕೆ ಎರಡು ಬಿಟ್ಟುಬಿಡಿ. ಓಕೆ, ದಟ್ಸ್ ಆಲ್ ಇಟ್ ಈಸ್. ಅವೆರಡು ಇಲ್ಲ ಅಂತಂದರೆ ಯು ವಿಲ್ ಬಿಕಮ್ ವಂಡರ್ಫುಲ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್. ಅವೆರಡೇ ಧೈರ್ಯ ಅನ್ನೋದನ್ನು ತೊಗೊಂಡೋಗುತ್ತೆ, ಭಯ ಅನ್ನೋದು ಹುಟ್ಟಿಸುತ್ತೆ. ಆದ್ದರಿಂದ ದಯವಿಟ್ಟು ಡೂ ದ್ಯಾಟ್. ದಟ್ಸ್ ದಿ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್. ಓಕೆ, ನಾವು ನಿನ್ನೆಯಿಂದ ಯು ಬೀನ್ ಹಿಯರಿಂಗ್ ಸೋ ಮೆನಿ ಲೆಕ್ಚರ್ಸ್. ಓಕೆ okay, right. Okay, you've been hearing so many lectures, so I'll do something else a little bit different. Okay, so what I want to show is we all know this. Now I will ask all of you to keep one scientist's name in your mind. Just close your eyes for 5 seconds, and there are so many scientists, good scientists, but keep one scientist who you think is very great in your view, in your own personal view, and remember that person. I'm not going to ask anybody, okay, just for your own sake. Just close your eyes for 5 seconds and decide one scientist whom you want to remember. Thank you all very much. Hopefully you have somebody in mind. So now I'll go on talking about this a little bit and try to understand whether the person you kept in your mind was a scientist or a technologist or an engineer. Okay, we want to distinguish this because at this age, because for the common man, everybody is a scientist. But it's very important for you to distinguish who is a scientist, who is a technologist, and who is an engineer. This is because you want to make a career in this. We want all of you to become one of these. ಆದ್ದರಿಂದ ನೀವು ಏನು ಯೋಚನೆ ಮಾಡಬೇಕಂದ್ರೆ, ನೀವು ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡಿದ್ದೀರಲ್ಲ ಅವರು ನಾನು ಹೇಳ್ತಾ ಹೋಗ್ತಾ ಇರ್ತೀನಿ, ದೆನ್ ಯು ಪ್ಲೀಸ್ ಅನಲೈಸ್ ಆ್ಯಂಡ್ ಸಿ ವೆದರ್ ಯು ಕೀಪ್ ವೆದರ್ ಇಟ್ಸ್ ಪಾಸಿಬಲ್ ಟು ಮೇಕ್ ದ ಡಿಸ್ಟಿಂಕ್ಷನ್. Okay, first is, can I change? Yeah, I'll do the change. Okay, before that, recently we had 28th February, which was called as the National Science Day. So, see, it's very interesting. When we celebrate the Science Day, we are not celebrating the birthday of somebody, but we are celebrating the day the effect was identified or seen for the first time. This is fantastic. I don't think it's anything like this has happened anywhere else in the world. ಅಲ್ವಾ, ಇಲ್ಲದೆ ಯಾರ್ದು ಹುಟ್ಟದಬ್ಬ ಮಾಡ್ತೀವಿ. ಹುಟ್ಟಿದ್ದು ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ಲ, ಏನು ಕೆಲಸ ಮಾಡ್ತಾರೆ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್ ಅಲ್ವಾ. ಆ ಕೆಲಸಕ್ಕೆ ರೆಕಗ್ನಿಷನ್ ಸಿಕ್ಕಿದ್ದು ಸಿ ವಿ ರಾಮನ್ದು 28th February. They saw the Raman effect for the first time. Okay, let's rediscover it as we go along. Okay, so ಕೆಳಗಡೆ ಇದೆ ಸಿ ವಿ ರಾಮನ್ and the picture next to him is K.S. Krishnan, the actual postdoctoral researcher who was working with him, and he was the one who actually saw the effect. Okay, and then called Professor Raman and told him that, hey, we have seen that, sir, what you have been telling for so many times, so long, we have seen it, and the K.S. Krishnan is there. Then Raman worked on several things. He worked on different kinds of crystals. If you go to Raman Research Institute in Bangalore, ಇದನ್ನ ಪ್ರಕೃತಿ ನೋಡ್ತಾರೆ. ಇದ್ಯಾಕೆ ನಕ್ಷತ್ರ ಇಲ್ಲಿ ಬಂತು, ಸೂರ್ಯ ಹಿಂಗೆ ಬಂತು, ಇಲ್ಲೇನಾದ್ರು, ಈ ಮರ ಹೆಂಗಿದೆ, ಗಿಡ ಹೆಂಗಿದೆ, ಎಲೆ ಈ ಶೇಪ್ ಯಾಕಿದೆ, ನಮ್ಮ ಮುಖ ಯಾಕೆ ಈ ತರ ಇದೆ, ನನ್ನ ಮುಖ ಈ ತರ ಯಾಕಿದೆ. ಓಕೆ, ಆಲ್ ದೀಸ್ ಕ್ವೆಶ್ಚನ್ಸ್. ಓಕೆ, ಸೊ ನೌ ಯು ಸಿ, then he also worked on musical instruments. His father was a musician. He got interest from that and he started working on musical instruments. He has a lot of research publications on musical instruments. In very high quality physics journals, he has published on musical instruments. Then, of course, a lot of recognition for him, etc. One small incident I just want to share with you. When he got the Nobel Prize, he went to receive the prize, and there the tradition is that everybody has champagne after to celebrate the Nobel Prize. So when he got it, but he is a teetotaler, he wouldn't drink alcohol. So he said, I don't want to drink this. So, but they all said, it's your event. Okay, today you are important. So you should, you should try it today for the first time. I think he gave a beautiful answer, which I want to share with you. He said that I only want to see the Raman effect on alcohol. I don't want to see the alcohol effect on Raman. So he didn't do that. So this is one of the events which was there. So let's celebrate the day. Yeah. Okay. Button, please. Yeah. Okay. Chapali hodiri avarige Ramange. Correct. Okay. Right. Next, please. So now look at this picture, right? So I'm sure hindugade kaantilla anta kanutte. We'll talk about scientists. Scientists are people who are just curious about nature. Nature ಬಗ್ಗೆ ಒಂದು ತರ ಕುತೂಹಲ ಅವರಿಗೆ. ಕುತೂಹಲದಲ್ಲಿ ಅವರು ಇದನ್ನ ಪ್ರಕೃತಿಯನ್ನು ನೋಡ್ತಾರೆ. ಇದು ಯಾಕೆ ನಕ್ಷತ್ರ ಇಲ್ಲಿ ಬಂತು, ಸೂರ್ಯ ಹಿಂಗೆ ಯಾಕೆ ಬಂತು, ಇಲ್ಲೇನಾಯ್ತು, ಈ ಮರ ಹೆಂಗಿದೆ, ಗಿಡ ಹೆಂಗಿದೆ, ಎಲೆ ಈ ಶೇಪ್ ಯಾಕಿದೆ, ನಮ್ಮ ಮುಖ ಯಾಕೆ ಈ ಥರ ಇದೆ, ನನ್ನ ಮುಖ ಈ ಥರ ಯಾಕಿದೆ. ಓಕೆ, ಆಲ್ ದೀಸ್ ಕ್ವೆಶನ್ಸ್ are very important. So they ask these natural questions about nature and they ask the question why. Every time they ask the question, yake, why is it like this, why is it like this, and keli, they are curious. You should understand, scientists are not doing something because they want to make something useful. They are just doing because of their curiosity, and that decided by the question, right? Let's see some of the scientists. Okay, next button. Yeah, you see here Einstein, Madam Curie, C.V. Raman, and our own boss, C.N.R. Rao. Right? So these are all scientists. So you can't ask them why you are doing this. What is the useful thing in the product, in the market? You can't ask these questions because they are doing out of curiosity. They want to try something, exchange this element, that compound, and see what is happening. That's what it is. Right? So next. So now what the scientist does is, okay. The scientist does is, they observe nature, find a pattern to it, and then convert it into a graph or an equation or a principle or a law. Okay, it may be a law, principle, graph, equation, something will be there, which will be general. And that is what comes into our textbooks. ಅವರೆಲ್ಲ ಮಾಡಿ ನೋಡಿ ಅದು ಪ್ಯಾಟರ್ನ್ ಕಂಡುಹಿಡಿದಿದ್ದನ್ನು ನಮ್ಮ ಪುಸ್ತಕದಲ್ಲಿ ಹಾಕ್ತಾ ಇರ್ತಾರೆ, which is established. That's what is in the book. So now what you have to do is, whenever you read something in the book, you should see where it exists in the world. ಅದು ಹೊರಗಿಂದ ಒಳಗೆ ತಂದಿದ್ದಾರೆ. ಈಗ ನಾವು ಎಜುಕೇಷನ್ ಅಂದರೆ ಒಳಗಿಂದ ಹೊರಗೆ ನೋಡೋದು ಅಂತ, ಅದು ಜಗತ್ತಲ್ಲಿ ಎಲ್ಲಿ ಕಾಣುತ್ತೆ ಅಂತ ಹುಡುಕ್ಬೇಕು ನಾವು. ಎವ್ರಿಥಿಂಗ್ ವಿ ರೀಡ್, ವಿ ನೀಡ್ ಟು ಸಿ ಇಟ್ ಇನ್ ದ ರಿಯಲ್ ವರ್ಲ್ಡ್. That is very important. Okay, this is what scientists do. So now after that you have technologists. What technologists do is this scientist found out this one, this scientist found out this one, this equation, e graph antella nodi, he'll put it together and say, I can make something, a mic out of it, I can make a mobile phone out of it, I can make a chair out of it, I can make a rocket out of it. Right? They put all the principles together and make something useful, and they are technologists. Okay, let's see some pictures of some technologists. Okay, so they ask the question. So you see, scientists only discover, they don't invent, right? But the technologists invent something. Okay, so invent, innovate, etc. And then you see, they are driven. Who are the scientists? Who are the technologists? Thomas Alva Edison, Alexander Graham Bell, Nikola Tesla, Benjamin Franklin, ಇವರೆಲ್ಲ. ನಾವು ಸ್ಕೂಲಲ್ಲೆಲ್ಲ ಇವ್ರನ್ನೆಲ್ಲ ಸೈಂಟಿಸ್ಟ್ ಅಂತಲೇ ಓದಿದ್ವಿ ನಾವು, ಅಲ್ವಾ? ಬಟ್ ಪ್ಲೀಸ್ ರಿಯಲೈಸ್, ಈಗ ನೀವು ಯೋಚನೆ ಮಾಡಿ, ನಿಮ್ಮ ಸೈಂಟಿಸ್ಟ್ ಏನು ತಲೆಯಲ್ಲಿ ಇಟ್ಟಿದ್ರಲ್ಲ, what they are scientists or technologists or engineers. Start thinking about that. So this is there. And then ultimately he says, I can make a mic out of it, I can make a bottle out of it, but somebody has to do it. Okay, and it is very important to do, just ಹೇಳೋದಲ್ಲ, ಮಾಡೋರ್ಬೇಕು. So who will do it? Okay, they are the engineers who do something. So if you want to, because ultimately you have to make a mic which is reliable, which works,
which is cheap, which is aesthetically good, it has to sell in the market, it has to be useful to people, etc. So that is the role of an engineer, right? So let's see engineers, their next question. They fabricate and innovate. So famous engineers for us is, you can see here, whom we very popular engineers in India are M. Visvesvaraya, of course, and then Abdul Kalam. But jana ಏನಂತಾರೆ ಹೊರಗೆ ಜಗತ್ತಲ್ಲಿ ಅಬ್ದುಲ್ ಕಲಾಮಿಗೆ ಸೈಂಟಿಸ್ಟ್ ಅಂತಾರೆ, because everybody is put under that name scientist. But essentially for students of science you should understand there is a distinction inside, because you have to make a career. Now I am telling all the three are equally important. There is nothing to say that this is more important than that one, right? But you have to think ನಿಮ್ಮ psychology ಯಾದಕ್ಕೆ ಇಷ್ಟ ಆಗುತ್ತೆ. How does your psychology help whether you want to become a scientist? That's why I said the person you kept in mind is probably whom your psychology attracts. Alva? Then you start thinking whether I can become a good engineer or a scientist or a technologist. I think that culture you need to develop. So during education, ಇದಾದ ತಕ್ಷಣ ನಂಗೆ ಇಂಜಿನಿಯರಿಂಗ್ ಸಿಕ್ಕಿಲ್ಲ, ನಾನು ಡಿಗ್ರಿಗೆ ಬಂದಿದ್ದೀನಿ, ಅದಕ್ಕೆ ಮುಗಿದೋದು ನನಗೆ ಸೈನ್ಸ್ ಬರಲ್ಲ, ಹಂಗಿಲ್ಲ. ಅಥವಾ ಡಿಗ್ರಿಗೆ ಬಂದಿದ್ದೀನಿ, ನಾನು ಇಂಜಿನಿಯರಿಂಗ್ ಅಲ್ಲ. ಇಟ್ ಈಸ್ ಅ ಮ್ಯಾಟರ್ ಆಫ್ ಆಟಿಟ್ಯೂಡ್ ಆಫ್ ಯು ಕ್ಯಾನ್ ಬಿಕಮ್ ಅ ನಾರ್ಮಲ್ to say graduate and still become an engineer. You will be doing engineering, you can become a scientist. It's all about your psychology, how you think about it. And that's what I want to show a little bit about scientists, how they do as they go along. Okay, so few great scientists. One is this fellow who is taking photographs. He is one great scientist, and the rest you see in the background. Okay, rest you see in the background. Okay, we all know this. Okay, J.C. Bose, okay, Prafulla Chandra, Satyendra Bose, Meghnad Shah, etc., etc. We know all these scientists who were well known in India. And of course, a few great engineers, okay, in different forms. There are also some engineers. I could not find really good technologists in some sense, in that sense. So maybe somebody can help me. Okay, later add some name as technologists in India. Nanu gottagilla. It's my ignorance.
JNCASR.
Thank you very much, sir.
Your previous question from Institute of Science, Bengaluru, and previous postdoctoral research.
I thank the organizers for giving this opportunity. Basically what I would like to do today would be to tell a couple of the problems in the area of fluid mechanics and engineering. And also while doing that, I thought connecting with nature, you may always think there is a bird which is flying, that is the way it generates its lift. Why engineers don't use that for building huge aircrafts or for transport? Okay, they always, you might have thought, no, actually ನಾವು ಹಾರಲಿಕ್ಕೆ ಕಲಿತಿದ್ದು ಅಥವಾ ಮಾಡಲಿಕ್ಕೆ ಶುರು ಮಾಡಿದ್ದು ಹಕ್ಕಿನ ನೋಡಿ, ಆದರೆ ಏರೋಪ್ಲೇನಲ್ಲಿ ಆ ಥರ ಆಗೋದಿಲ್ಲ ಅಲ್ವಾ? ದೇರ್ ಇಸ್ ಎ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ವಾಟ್ ಏರ್ಕ್ರಾಫ್ಟ್ ಡಸ್ ಆ್ಯಂಡ್ ವಾಟ್ ಎ ಬರ್ಡ್ ಡಸ್. ದೇರ್ ಇಸ್ ಎ ರೀಸನ್ ಫಾರ್ ಇಟ್. ಲೆಟ್ಸ್ ಗೋ ಥ್ರೂ ದಟ್ ಒನ್. I will keep it brief, and what I would like to do is that I will just expose you to the different aspects. We can have discussion later because of the time constraint. I will go through explaining what is the important factors. Later we can discuss. Okay. Next slide. Apart from insect flight, I also work on other problems. Atmospheric boundary layer, wherein which we are looking into the behavior of atmosphere in the night time, and turbulent drag reduction. When you want to pump fluid over a large distance, turbulence is one of the things. It's the state of the flow. ಅದೇನಾಗುತ್ತೆ ಅಂತಂದರೆ ಲಾಸಸ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡುತ್ತೆ. ಅದನ್ನು ಯಾವ ಥರ ರೆಡ್ಯೂಸ್ ಮಾಡೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ರಿಸರ್ಚ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಏರೋಡೈನಮಿಕ್ಸ್ ಆಫ್ ಇನ್ಸೆಕ್ಟ್ ಫ್ಲೈಟ್, ಟುಡೇ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟಚ್ ಅಪಾನ್ ಇಟ್. ಮುಂದೆ ನಾವು ಅಟ್ಮಾಸ್ಫಿಯರ್ ಒಳಗಡೆಗೆ ನೀವು ವೆದರ್ ಪ್ರಿಡಿಕ್ಷನ್ಗೆ ಇರಬಹುದು, ಅಥವಾ ಮಳೆ ಬರುತ್ತೆ ಇಲ್ಲ ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಇರಬೇಕು, ಅದನ್ನು ಪ್ರಿಡಿಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ಅದು ಹೆಲ್ಪ್ ಮಾಡುತ್ತೆ. ಇನ್ನೊಂದು ಸೈಂಟ್ ಮೇರಿ ಐಲ್ಯಾಂಡ್ ಅಂತ ಹೇಳಿ ನಿಮಗೆ ಇಲ್ಲೇ ಬಹಳ ಹತ್ತಿರದಲ್ಲಿ, ಉಡುಪಿ ಹತ್ತಿರದಲ್ಲಿ ಒಂದು ದ್ವೀಪ ಇದೆ. ಅಲ್ಲಿ ನೀವು ಹೋಗಿ ನೋಡಿದ್ರೆ ನಿಮಗೆ ಅಲ್ಲಿ ಕಣ್ಣಿಗೆ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ, ಎಲ್ಲ HB ಪೆನ್ಸಿಲ್ಸ್ ಒಟ್ಟೊಟ್ಟಿಗೆ ಕೂಡಿಸಿದ ಹಾಗೆ ಜಿಯಾಲಜಿಕಲ್ ಫಾರ್ಮೇಷನ್ ಇದೆ. ಅದು ಯಾಕಾಯಿತು? ಓಕೆ, ಅದನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಲ್ಯಾಬೊರೇಟರಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಆ್ಯಂಡ್ ಅದರ್ ಥಿಂಗ್ಸ್ ವಿ ಟ್ರೈ ಟು ಡೂ. ಅದೊಂದೇ ಅಲ್ಲ, ಸಮುದ್ರದೊಳಗಡೆಗೆ ನೀರು ವರ್ಟಿಕಲ್ ಆಗಿ ಅದು ಯಾವ ಥರ ಮೂವ್ ಆಗುತ್ತೆ, ಮಿಕ್ಸಿಂಗ್ ಆಗುತ್ತೆ, ಅದನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದ್ರ ಬಗ್ಗೆನೂ ನಮ್ಮ ಗುಂಪಲ್ಲಿ ನಾವು ವರ್ಕ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ನೆಕ್ಸ್ಟ್ ಒನ್. Yeah, these are some other examples like geoconvection. You can see ಒಂದು ಆ ಕಡೆ ತುದಿಲಿರುವಂತಹ ಒಂದು ಇದರೊಳಗಡೆಗೆ ನಿಮಗೆ ಇದೆಲ್ಲ ಲ್ಯಾಬೊರೇಟರಿ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್. ಇಟ್ಸ್ ನಾಟ್ ಲಾರ್ಜ್ ಸ್ಕೇಲ್. ಯು ಕ್ಯಾನ್ ಈವನ್ ಡೂ ಇಟ್ ಇನ್ ಯುವರ್ ಲ್ಯಾಬ್ ಹಿಯರ್. ಓಕೆ, It doesn't require, it's a water and some solutions which will help you to fluorescent dye ಹಾಕಿದೆ. ಅದ್ರ ಮೂಲಕ ಆ ಒಳಗಡೆ ಇರುವಂತಹ ಪ್ಲೂಮ್ಸ್ ಅಂದರೆ ಬಯಾನ್ಸಿ ಈಗ ಹೊಗೆ ಬಂದಾಗ ಯಾವ ಥರ ಬರುತ್ತಲ್ಲ ಅದೇ ಥರ ಅದು ಬಂದು ಯಾವ ಥರ ಮಿಕ್ಸ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಅದೇ ಥರ ಇನ್ನೊಂದು ಈ ಕಡೆ ಒಳಗಡೆಗೆ ಒಂದು ವಾಲ್ಕನಿಕ್ ಕಂಡೀಷನನ್ನು ಮಿಮಿಕ್ ಮಾಡುತ್ತೆ, ಅಂದರೆ ವಾಲ್ಕನಿಕ್ ಕಂಡೀಷನಲ್ಲಿ ಯಾವ ಥರ ಆಗುತ್ತೆ ಅಂತ. ಇನ್ನೊಂದು ಹಿಮಾಲಯದ ಕೆಳಗಡೆಗೆ ಪ್ಲೇಟ್ ಟೆಕ್ಟಾನಿಕ್, ಅಂದರೆ ನಮ್ಮ ಭೂಮಿಯ ಪದರ ಏನಿದೆ ಭೂಮಿ ಒಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ ಹಿಮಾಲಯದ ಕೆಳಗೆ, ಅದಕ್ಕೋಸ್ಕರ ಹಿಮಾಲಯ ಮೇಲೆ ಬಂದಿದೆ. ಅದು ಶೀಟ್ ಥರ ಹೋಗುತ್ತೆ. ನಿಮ್ಗೆ ಅವೆರಡರ ನಡುವೆ ಡಿಫ್ರೆನ್ಸ್ ಏನಿದೆಯಲ್ಲ, ಯಾಕೆ ಆ ಥರ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ಲ್ಯಾಬ್ರೇಟರಿ ಒಳಗಡೆ ನೋಡ್ತಾ ಇದ್ದೀವಿ. ನೆಕ್ಸ್ಟ್ ಒನ್, ಐ ಆಲ್ಸೋ ಸೆಡ್ ಟರ್ಬುಲೆಂಟ್ ಡ್ರ್ಯಾಗ್ ರಿಡಕ್ಷನ್ ಅಂತಂದರೆ ಪೈಪ್ ಒಳಗಡೆಗೆ ನೀವು ಯಾವುದೇ ದ್ರವನ ಬಹಳ ದೂರ ಸಾಗಿಸ್ಬೇಕಾದ್ರೆ, ಈಗ ಆ ಥರದ್ದು ಎಲ್ಲಾಗುತ್ತೆ ಅಂತಂದರೆ ಆಯಿಲನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಅದನ್ನು ಹೊರಗಡೆಗೆ ತೊಗೊಂಡೋಗ್ಲಿಕ್ಕೋಸ್ಕರ ಪೈಪ್ ಮೂಲಕ ಅದನ್ನು ದಬ್ತಾರೆ. ಅವಾಗ ನಿಮಗೆ ಲಾಸಸ್ ಬರುತ್ತೆ. ಅದನ್ನು ಯಾವ ಥರ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಅದೆಲ್ಲ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸು ಮತ್ತು ಸಿಮ್ಯುಲೇಷನ್ ಮಾಡ್ತೇವೆ ನಮ್ಮ ಗ್ರೂಪಲ್ಲಿ. ಇನ್ನೊಂದು ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಒಳಗಡೆಗೆ ನಾನು ಹೇಳಿದೆ, ರಾತ್ರಿ ಒಳಗಡೆಗೆ ಅದರದ್ದು ವಾತಾವರಣದಲ್ಲಿ ಯಾವ ಥರ ಚೇಂಜ್ಗಳಾಗುತ್ತೆ ಅಂತ ಹೇಳಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ ಅಂತ. ಯಾಕೆ ಮಾಡ್ತಿದ್ವಿ ಅಂತಂದರೆ, ಈಗ ಬೆಂಗಳೂರು ಏರ್ಪೋರ್ಟ್ನವರು ನಮಗೆ ಈ ಒಂದು ಪ್ರಾಬ್ಲಮನ್ನು ಸ್ಟಡಿ ಮಾಡಲಿಕ್ಕೆ ಹೇಳಿದರು. ಏನಂತಂದರೆ ಅವರಿಗೆ ವಿಂಟರ್ ಟೈಮಲ್ಲಿ ಫಾಗ್ ಆಗುತ್ತಲ್ಲ, ಯಾವ ಟೈಮಲ್ಲಿ ಫಾಗ್ ಆಗುತ್ತೆ, ಯಾವ ಟೈಮಲ್ಲಿ ವಿಸಿಬಿಲಿಟಿ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಯಾಕಂತಂದರೆ ಅವ್ರಿಗೆ ಏರ್ಕ್ರಾಫ್ಟು ಹ್ಯಾಂಡಲ್ ಮಾಡೋದು ಕಷ್ಟ ಆಗುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ ಏನು ಮಾಡ್ತಿದ್ವಿ ಅಂದರೆ, ನಮ್ಮ ಗ್ರೂಪಲ್ಲಿ ನಾವು ದಿನಾರ್ ಸಾಯಂಕಾಲ 7 ಗಂಟೆಗೆ ಏರ್ಪೋರ್ಟ್ನವ್ರಿಗೆ ಅವತ್ತಿನ ಬೆಳಗ್ಗೆ ಯಾವ ಥರ ಫಾಗ್ ಆಗುತ್ತೆ, ಯಾವ ಟೈಮಲ್ಲಿ ಆಗುತ್ತೆ ಅಂತ ಆ ಥರ ಚಾರ್ಟನ್ನು ಪ್ರತಿ ದಿನಾನೂ ಕೊಡ್ತಾ ಇದ್ವಿ. ಅದ್ರ ಸಕ್ಸಸ್ ರೇಟ್ ಬಂದು 75% ಅಷ್ಟು ನಾವು ಅಚೀವ್ ಮಾಡಿದ್ವಿ ಓವರ್ ಅ ಪೀರಿಯಡ್ ಆಫ್ 4 years ಆಫ್ ಸ್ಟಡಿ. ನಾವು ವಿ ಹ್ಯಾವ್ ಎ ಪ್ರೋಗ್ರಾಮ್ ವಿಚ್ ಯೂಸಸ್ ಲಾಟ್ ಆಫ್ ಡಾಟಾ, ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಇದನ್ನು ಅಡಾಪ್ಟ್ ಮಾಡಿಕೊಂಡು ನಾವು ಅದರೊಳಗಡೆಗೆ, ನೀವು ಏರ್ಪೋರ್ಟ್ ಒಳಗಡೆ ಹೇಳಿದ್ರೆ ಆ ರನ್ವೇ ಪಕ್ಕದಲ್ಲೇ ನಮ್ಮ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸು ಇದೆ, ಅರೌಂಡ್ 280 to 300 meters from the midline old runway. There are 2 runways in Bangalore. The old one, north side one, we have deployed our equipment and we have collected the data. Based on that, you need data. One thing you have to remember, data science, ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್, ಮಷಿನ್ ಲರ್ನಿಂಗ್ ಎಲ್ಲ ಹೇಳ್ತಾರಲ್ಲ, ಅದಕ್ಕೆ ನಿಮಗೆ ಡಾಟಾ ಬೇಕು. ಓಕೆ, ಡಾಟಾ ಇಲ್ದಿರ ಯಾವಾಗೋದಿಲ್ಲ. ಡಾಟಾ ಮಾಡಬೇಕಾದ್ರೆ ನೀವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಬೇಕು. ಮೆಕ್ಯಾನಿಕಲ್ ಇಂಜಿನಿಯರ್ ಇರ್ಬೋದು, ಕೆಮಿಕಲ್ ಇರ್ಬೋದು, ಮತ್ತು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇರ್ಬೋದು. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಡಾಟಾ ಬಂದ ಮೇಲೆ ಕಂಪ್ಯೂಟರ್ ಸೈನ್ಸ್ನವ್ರು ಬಂದು ನಾವು ಅದನ್ನು ಅನಲೈಸ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಆ ದೃಷ್ಟಿಯೊಳಗಡೆ ನೋಡಬೇಕಾದ್ರೆ ಈ ಥರದ ಸೈನ್ಸು ವೇರ್ ನಿಮಗೆ ಡಾಟಾನ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದು, ಅದ್ರ ಬಗ್ಗೆ ಫಿಸಿಕ್ಸನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಿದೆಯಲ್ಲ, ಅದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಅದ್ರ ಬೇಸಿಸ್ ಮೇಲೆ ವಿ ಕುಡ್ ಏಬಲ್ ಟು ಡೂ ಇಟ್. ಅದರ ಒಂದು ಲಾಸ್ಟ್ ಅಲ್ಲಿ ತೋರಿಸ್ತಾ ಇರೋದು ಇದು ವರ್ಟೆಕ್ಸ್ ರಿಂಗ್ ಅಂತೀವಿ. ನೀವು ಹಿಂದಿನ ಕಾಲದ ಮೂವಿ ಒಳಗಡೆಗೆ ಸ್ಮೋಕ್ ಮಾಡಿ ಹೊಗೆಗಳ ರಿಂಗ್ಗಳನ್ನ ಬಿಡ್ತಾ ಇದ್ರಲ್ಲ, ಅದೇ ಥರನೇ ಇದು ನೀರೊಳಗಡೆ ಮಾಡಿರುವಂಥದ್ದು. ಇದು ಹೋಗಿ ನಿಂತು ವಾಪಸ್ ಬರ್ತಾ ಇದೆ. ಯಾಕಂತಂದರೆ ಅದರೊಳಗಡೆಗೆ ಎಲಾಸ್ಟಿಸಿಟಿ ಇದೆ. ಫಸ್ಟ್ ಆ್ಯಂಡ್ ಫಾರ್ಮೋಸ್ಟ್, ಆಸ್ ಐ ಸೆಡ್, ಈಸ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಆರ್ birds and insects are small in size compared to whatever we see aircraft. Even though we started our inspiration from the birds and insects to fly, the sizes are very different, speeds are very different, loads are very different. There are application, very interesting one. Our friend here yesterday, he took our micro, we call it micro vehicle or unmanned drones, which are all small size, can have many applications like aerial photography, surveillance, police for monitoring the traffic. And I was also asking him, if there is a fog formation, I want to understand the fog physics, wherein which I can put the instrument and fly through. What they do is that they move their wing in 8 shape, okay, and generate a force always normal to the wing. That is done by like this. Okay, now I am, even though doing my wing back and forth motion, always the fan is rotating in only one direction. That means always it is going normal to this. Rotating this guy means producing the force normal to the surface. That is the motion what the bird will do, hummingbird or anything. Okay, very efficient, which are very lightweight and have generate a lot of lift but very little drag, so that it can, for if you drop from 1 meter height, it may go for 8-9 meters. From 1 meter height, it can fly for 10 meters before hitting the ground. It has a glide ratio of 10. Okay, you need to have higher glide ratio if you want to use gliding as a means of flying. Go to the next one. something called air current. Sometimes if there is a mirror, there is a breeze. What will happen is that ಗಾಳಿ ಬಂದು ಗುಡ್ಡಕ್ಕೆ ತಡೆದು ಮೇಲೆ ಹೋಗುತ್ತಲ್ಲ ಅದ್ರ ಮೇಲ್ಗಡೆ ಹೋಗಿ ಕೂತ್ಕೊಳ್ತಾರೆ. ನಾವೇನು ಕೆಲಸ ಮಾಡೋದಿಲ್ಲ, ಆ ಏರ್ ಗಾಡಿ ಒಳಗಡೆ ಬರುವಂತಹ ಮೂಮೆಂಟ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ದೇವ್ ಫ್ಲೈ.
Thank you. Thank you. ಇದನ್ನೇ ಯೂಸ್ ಮಾಡೋಣ.
Thank you, sir. Over to you. Thank you.
So, good morning, ellarguno. Today is International Women's Day. So, we will actually make an exception today. Normally, what we do is when we call volunteers, we get both boys and girls. But today, because it is International Women's Day and we want more of women participation in science, we will request only women to come forward as volunteers. Okay? So, let's give all the women a very big hand. Okay? And women should come forward, participate more, go further than men. Okay? And do many more things, come up in life. So, let's start our science experiments.
ಬೇರೆ ಏನು ಬೇಕಾದ್ರೆ ಹೇಳಿ, ನೀವು ಯಾರಾದ್ರೂ ಇನ್ಸಲ್ಟ್ ಮಾಡಿದ್ರೆ ಟೇಕ್ ಇಟ್ ಪಾಸಿಟಿವ್. ಎಷ್ಟು ಇನ್ಸಲ್ಟ್ ಆಗ್ತಿದೆ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಲರ್ನ್ ದಟ್.
ಇರಿ ಇನೋವೇಷನ್ ಆಫ್ ನೇಚರ್. ಇನೋವೇಷನ್ ಬಂದ್ರೆ ಏನು ಮಾಡ್ತೀರಾ ನೀವು? ವಾಟ್ ಯು ಡೂ? ವಿಲ್ ಡೂ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್, ರೈಟ್? ಓಕೆ. ಇನ್ವೆನ್ಷನ್ ಅಗೇನ್ ಮತ್ತೆ ಡಿಸ್ಕವರಿ ಅದನ್ನೇ ಹೇಳ್ತಾ ಇದ್ದೀರಾ, ಮತ್ತೆ ಬೇರೆದು ಹೇಳಿ ಏನಾದ್ರು. ಈಗ ಸೈನ್ಸ್ ಅಂದ್ರೆ ಏನಪ್ಪ, ಏನು ಮಾಡ್ತೀವಿ ನಾವು ಯೂಶುವಲಿ?
ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್.
ಓಕೆ, ಅಬ್ಸರ್ವೇಷನ್ ಮಾಡಬೇಕು, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತಾರೆ ಅವರು. ಓಕೆ, ಇವಾಗ ನೀವೆಲ್ಲರೂ ಹೇಳಿದ್ರಿ ಗಾಯ್ಸ್, ನೀವೆಲ್ಲರೂ ಹೇಳಿದ್ರಿ, ಏನು ಹೇಳಿದ್ರಿ ಅಂತಂದ್ರೆ ದ ಸ್ಟಡಿ ಆಫ್ ಸರೌಂಡಿಂಗ್ ಥಿಂಗ್ಸ್ ಆ್ಯಂಡ್ ನೇಚರ್ ಬಗ್ಗೆ ಹೇಳಿದ್ರಿ. ಯು ಶುಡ್ ಹ್ಯಾವ್ ದ ಕ್ಯೂರಿಯಾಸಿಟಿ, ಹೌದಲ್ವಾ? ಅದು ಯಾಕೆ ಹಾಗಿದೆ ಅಂತ ಕ್ವಶನ್ ಕೇಳಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. ದೆನ್ ಆ ಕ್ವಶನ್ ಯಾವಾಗ ಕೇಳಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ, ಯು ಸ್ಟಾರ್ಟೆಡ್ ಅಬ್ಸರ್ವಿಂಗ್ ಸಮಥಿಂಗ್, ಹೌದಲ್ವಾ? ಆ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ಮೇಲೆ ಹೇಗೆ ನಡೀತಾ ಇದೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಏನು ಮಾಡ್ತಾರೆ, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡೂ ಅ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಟೆಲ್ ಮಿ ಎಸ್ ಆರ್ ನೋ? ಓಕೆ, ಯು ವಿಲ್ ಡೂ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಫೈನಲಿ ನಾನು ಹೇಳಿರ್ತೀನಿ, ಇವಾಗ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ವಾಟರ್ ಬಾಟಲ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಐ ಹ್ಯಾವ್ ಅ ವಾಟರ್ ಬಾಟಲ್ ಹಿಯರ್, ಇದು ಕಂಪ್ಲೀಟಾಗಿ ಫಿಲ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಓಕೆ, ನೀವು ಚೆಕ್ ಮಾಡ್ತೀರಾ ಅದನ್ನ ಬಂದ್ಬಿಟ್ಟು. ಇವಾಗ ಸಪೋಸ್ ಇದು ಪ್ಲಾಸ್ಟಿಕ್ ಇದ್ರೆ ಡಯಾಮೀಟರ್ ಇಷ್ಟೇ ಇದೆ ಅಂತ ಹೇಳ್ತೀನಿ. ವಾಟ್ ವಿಲ್ ಡೂ, ಇವಾಗ ಈ ವಾಟರ್ ಬಾಟಲ್ ನನ್ನ ಕೈಲಿ ಇಲ್ಲಿಂದ ಹೀಗೆ ತೊಗೊಂಡ ತಕ್ಷಣ ನೀವೇನು ಮಾಡ್ತಾ ಇದ್ರಿ? ಈ ವಾಟರ್ ಬಾಟಲ್ ನೋಡ್ತಾ ಇದ್ರಲ್ಲ, ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇದ್ರಲ್ವಾ? ಇವಾಗ ನಾನು ಹೇಳ್ತೀನಿ ಅಕ್ಯುರೇಟ್ ಆಗಿ ಇಷ್ಟೇ ಡಯಾಮೀಟರ್ ಇದೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಇವಾಗ ನೀವೆಲ್ಲ ಸೈನ್ಸ್ ಸ್ಟೂಡೆಂಟ್ಸ್ ಏನು ಮಾಡ್ತೀರಾ? ಸರ್ ಹೇಳಿದಾರೆ ಇಷ್ಟು ಅಕ್ಯುರೇಸಿ, ಹೆಂಗೆ ಹೇಳಿದ್ರಪ್ಪ ಇವರು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ವಿಲ್ ಗೋ ಟು ದ ಲ್ಯಾಬ್ರೋಟರಿ. ಯು ವಿಲ್ ಟೇಕ್ ದ ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್ ಆರ್ ದ ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್ ಯೂಸ್ ಮಾಡ್ತಿರಲ್ಲ ಡಯಾಮೀಟರ್ ಆಫ್ ದ ಆಬ್ಜೆಕ್ಟ್ನ ಇದು ಮಾಡೋಕ್ಕೆ, ಸಿಲಿಂಡರ್ನ. ದೆನ್ ಇದು ನಂದಲ್ಲ. ಓಕೆ, ಇಲ್ಲಿದೆ, ಇಲ್ಲಿ ಆಫ್ ಮಾಡಿದ್ರೆ ಮುಗೀತು. ಓಕೆ, ವರ್ನಿಯರ್ ಕ್ಯಾಲಿಪರ್ ತಗೋತೀರಾ, ಅದನ್ನು ಮೆಜರ್ ಮಾಡ್ತೀರಾ, ಹೌದಲ್ವಾ? ದೆನ್ ಫೈನಲಿ ಯು ವಿಲ್ ಕನ್ಕ್ಲೂಡ್, ಯು ವಿಲ್ ಅನಾಲಿಸಿಸ್. ಸರ್ ಹೇಳಿದ್ರು ಇಷ್ಟೇ ಆನ್ಸರ್ ಬರುತ್ತೆ ಅಂತ. ದೆನ್ ಐ ಗಾಟ್ ಎಕ್ಸಾಕ್ಟ್ ಆನ್ಸರ್. ಯು ವಿಲ್ ವೆರಿಫೈ ದಟ್. ಓಕೆ, ಸೈನ್ಸ್ ಈಸ್ ಸಿಸ್ಟಮೆಟಿಕ್ ನಾಲೆಜ್ ಗೇನ್ಡ್ ಬೈ ಕೇರ್ಫುಲ್ ಅಬ್ಸರ್ವೇಷನ್, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ದಟ್ ಫೈನಲಿ ವಾಟ್ ವಿಲ್ ಡೂ ವೆರಿಫೈ, ರೈಟ್? ಸುಮ್ಮನೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಮೆಸೇಜ್ ಬಂದಿರುತ್ತೆ ನಮಗೆ, ಇದನ್ನ ಕರಿಬೇವು ಒಂದು ಸ್ವಲ್ಪ ಹಾಕಿ, ಈರುಳ್ಳಿ ಒಂದು ಸ್ವಲ್ಪ ಹಾಕಿ ಎಲ್ಲ ಮಿಕ್ಸ್ ಮಾಡಿಬಿಟ್ಟು ಮುಖಕ್ಕೆ ಹಚ್ಕೊಂಡ್ಬಿಟ್ರೆ ಗೋಲ್ಡನ್ ಇದು ಬರುತ್ತೆ, ಶೈನಿಂಗ್ ಬರುತ್ತೆ, ಪ್ಲೀಸ್ ಶೇರ್ ಟು ಅದರ್ ಗ್ರೂಪ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. ನೆವರ್ ಡೂ ದಟ್ ಮಿಸ್ಟೇಕ್, ಬಿಕಾಸ್ ಯು ಆರ್ ಆಲ್ ಸೈನ್ಸ್. ಯು ವಿಲ್ ವೆರಿಫೈ. ಆಮೇಲೆ ಹೇಳ್ತೀರಾ, ಅದ್ರ ಕೆಳಗಡೆ ಚಿಕ್ಕದಾಗೆ ಬರ್ದಿರ್ತಾರೆ ವಾಟ್ಸಪ್ಪಲ್ಲಿ, ಇದು ನಾಸಾದಿಂದ ವೆರಿಫೈ ಮಾಡಿದ್ದಾರೆ ಅಂತ. ಓಕೆ, ನೆವರ್ ಬಿಲೀವ್ ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಫಾರ್ವರ್ಡ್ ಮೆಸೇಜಸ್. ನಿಮ್ಗೆ ಏನಾದ್ರು ಪಕ್ಕಾ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ವೆರಿಫೈ ಮಾಡಿ ನಿಮಗೆ ಕನ್ಫರ್ಮ್, ಅದು ಡಬಲ್ ಟ್ರಿಬಲ್ ರೀಪ್ರೊಡ್ಯೂಸಿಬಿಲಿಟಿ ಆದಾಗ ಮಾತ್ರ ಯು ಜಸ್ಟ್ ಫಾರ್ವರ್ಡ್ ದಟ್ ಮೆಸೇಜಸ್. ಓಕೆ, ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನೋದು ತುಂಬ ಇಂಪಾರ್ಟೆಂಟು. ವಿತೌಟ್ ದ್ಯಾಟ್ ಡೋಂಟ್ ಬಿಲೀವ್. ಯು ಸ್ಟಾರ್ಟ್ ಆಸ್ಕಿಂಗ್ ಕ್ವಶನ್ ಕೇಳಬೇಕು ಪ್ರತಿಯೊಂದಕ್ಕೂ. ಆ ಕ್ವಶನ್ ಕೇಳಬೇಕು ಅಂದರೆ ನಿಮ್ಮ ಹತ್ರ ಆ ಒಂದು ಖುಷಿ ಇರಬೇಕು, ಆ ಒಂದು ಫೀಲ್ ಇರಬೇಕು, ಆ ಒಂದು ಕ್ಯೂರಿಯಾಸಿಟಿ ಇರಬೇಕು. ಓಕೆ, ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ಅವರ್ ದ ಬಿಸ್ನೆಸ್. ಓಕೆ, ನನ್ನ ಹತ್ರ ಒಂದು ಸಿಂಪಲ್ ಪೇಪರ್ ಇದೆ ನೋಡಿ. ಒಂದು ಪೇಪರಿಂದ ಎಂತಿಂಥ ಡೈನಾಮಿಕ್ಸ್ನ ನೀವು ಕಲಿಬಹುದು. ದ ಏರೋಡೈನಾಮಿಕ್ಸ್, ದ ಲಾಸ್ ಆಫ್ ಫಿಸಿಕ್ಸ್. ಓಕೆ, ಐ ಹ್ಯಾವ್ ಅ ಪೇಪರ್ ಎ ಟೀಮ್ ಎ. ಇಟ್ ಈಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ನಿಮಗೆ ಅವ್ರಿಗೆ ಕಾಂಪಿಟೇಷನ್, ಈಗ ದೊಡ್ಡ ಕಾಂಪಿಟೇಷನ್ ಇದು. ಏನು ಸರ್ ಒಂದು ಪೇಪರಲ್ಲಿ ಕಾಂಪಿಟೇಷನ್ ಅಂತಿರಲ್ಲ ಅಂತ ಅನ್ಬೋದು ನೀವು. ಓಕೆ, ಐ ವಿಲ್ ಜಸ್ಟ್ ಆಸ್ಕ್ ಯು ಅ ಕ್ವಶನ್, ಟೀಮ್ ಎ ಆ್ಯಂಡ್ ಟೀಮ್ ಬಿ. ಓಕೆ, ಬಿ ಪ್ರಿಪೇರ್, ಡೋಂಟ್ ಹೆಲ್ಪ್ ದೆಮ್, ಯು ಕ್ಯಾನ್ ಹೆಲ್ಪ್ ದೆಮ್ ಲೇಟರ್. ಐ ಹ್ಯಾವ್ ಅ ಪೇಪರ್ ಹಿಯರ್, ಕ್ಯಾನ್ ಯು ಸಿ ದ ಪೇಪರ್? ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ?
ಈ ಪೇಪರ್ ಹೆಂಗೆ ಸ್ಟ್ರೇಟ್ ಆಗಿ ನಿಂತ್ಕೊಂಡಿದ್ದಾನ ಹೇಗೆ ಬಿದ್ದಿದ್ದಾನ, ಅದು ಡೌನಲ್ಲಿದ್ದಾನ, ಡ್ಯೂ ಟು ಗ್ರಾವಿಟಿ ಇದು ವೇಟ್ ಇದೆ ಪೇಪರ್ಗೆ, ಅದಕ್ಕೆ ಕೆಳಗಡೆ ಬಿದ್ದಿದೆ. ಹೌದಾ? ಟೀಮ್ ಎ. ಇವಾಗ ನಾನು ಈ ಏರ್ನ ಈಗ ಇಲ್ಲಿಂದ ಗಾಳಿನ ಊದ್ತಾ ಇದ್ದೀನಿ, ಈ ಕೆಳಗಡೆಯಿಂದ ಗಾಳಿನ ಊದ್ದೆ, ಏನಾಗುತ್ತೆ? ಲಿಫ್ಟ್ ಆಗುತ್ತಾ ಇಲ್ಲ? ಟೀಮ್ ಎ ಲಿಫ್ಟ್. ಈಗ ಇಲ್ಲಿಂದ ಕೆಳಗಡೆಯಿಂದ ಗಾಳಿ ಊದಿದ್ರೆ ಉಫ್ಫತ್ತ ಆಗುತ್ತಾ? ಓಕೆ. ವಾಟ್ ಅಬೌಟ್ ಟೀಮ್ ಬಿ? ಟೀಮ್ ಬಿ ಬೇಗ ಯೋಚನೆ ಮಾಡಿ. ಸರ್ಪ್ರೈಸ್ ಗಿಫ್ಟ್ ಅಂತ ಹೇಳಿದೀನಿ, ಅದು ಕೊಡಲ್ಲ ಅಂತಾನು ಹೇಳಿದೀನಿ. ಓಕೆ. ಟೀಮ್ ಬಿ ಲಿಫ್ಟ್ ಆಗುತ್ತಾ ಆಗಲ್ಲ? ಟೀಮ್ ಬಿ ನೀವು ಮೇಲ್ಗಡೆ ಲಿಫ್ಟ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಟ್ರೈ ನಾವು. ಓಕೆ, ಲಿಫ್ಟ್ ಆಯ್ತು. ಎಲ್ಲರೂ ಕ್ಲಾಸ್ ಹಾಕಿ ನೋಡೋಣ. ಈಗ ಇನ್ನೊಂದು ಚಾಲೆಂಜ್ ಇದೆ. ಇಟ್ಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ನೋಟ್ ಹಿಯರ್ ಬಿಕಾಸ್ ಇದ್ರಲ್ಲಿ ತುಂಬಾ ಕಾನ್ಸೆಪ್ಟ್ ನೀವೇ ಡೆಫಿನಿಷನ್ ಬರೀತೀರಾ. ರಿಮೆಂಬರ್, ಓಕೆ? ನಾವು ಈಗಿದೆ ಆಟ, ಇವಾಗ ಕರೆಕ್ಟ್ ಆಗಿ ಆನ್ಸರ್ ಮಾಡಬೇಕು. ಈಗಾಗಲೇ ಕೆಳಗಡೆಯಿಂದ ಊದಿದ್ದೆ, ಲಿಫ್ಟ್ ಆಗಿತ್ತು. ಇವಾಗ ಮೇಲ್ಗಡೆಯಿಂದ ಗಾಳಿನ ಊದ್ತೀವಿ. ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್? ಲಿಫ್ಟ್ ಆಗುತ್ತೋ ಇಲ್ಲೋ? ಟೀಮ್ ಎ ಆಗಲ್ಲ. ಓಕೆ, ಟೀಮ್ ಬಿ ಆಗಲ್ಲ. ಓಕೆ, ಬಿಗ್ ರೌಂಡ್ ಆಫ್ ಅಪ್ಲಾಸ್ ಫಾರ್ ಅವರ್ ಹೋಲ್ ಬಿಗ್ ಟೀಮ್. ಟೀಚರ್ಸ್, ಓಕೆ ಟೀಚರ್ಸ್, ಈಗ ಇಲ್ಲಿಂದ ಮೇಲ್ಗಡೆಯಿಂದ ಗಾಳಿನ ಊದ್ತೀವಿ, ಲಿಫ್ಟ್ ಆಗುತ್ತೋ ಆಗಲ್ಲ? Who will say ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾರು? ದಯವಿಟ್ಟು ಬನ್ನಿ ಇಲ್ಲಿ ಮೇಲೆ. ಸುಮ್ಮನೆ ಈಗ ಒಂದು ರೇಸ್ ನಡೆದಿತ್ತು, ಅಲ್ಲಿ ನಾನು ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಬಂದು ಕೇಳ್ತಾ ಇರ್ತಾರೆ ಎಷ್ಟು ಜನ ರೇಸ್ ಆಗ ಅಂದ್ರೆ ಇಬ್ರು ಅಂತ. ಹಂಗಾಗಿ ರೇಸ್ ಅನ್ನು ಅಂತ ಹೇಳಿದ್ರೆ ಹೆಸರು ಯಾರು ಇಷ್ಟ ಆಗುತ್ತೆ
ಆಗಿಲ್ಲ ಅನ್ಕೊಂಡು
ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. ನೀವೆಲ್ಲ ಹೇಳೋದೆಲ್ಲ ರಾಂಗ್ ಮಾಡೋದು.
See, in this kettle, I have some hot water. ಬಿಸಿನೀರು ಇದೆ. ಓಕೆ, ನಾನೇನು ಮಾಡ್ತೀನಿ, ಆ ಬಿಸಿನೀರನ್ನ ಈ ಬಾಟಲಲ್ಲಿ ಹಾಕ್ತೀನಿ. ಓಕೆ, ಅಲ್ಲ ನೀವು ಮಾಡಿ ಇದನ್ನ. ಓಕೆ, ವಾಲಂಟಿಯರ್ಸ್ ಕರೆಯೋಣ. ಯು ಕ್ಯಾನ್ ಡೂ ಇಟ್. ಓಕೆ, ವಿನಾಯಕ್ ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ, ಬಿಸಿನೀರನ್ನ ಅದರಲ್ಲಿ ಹಾಕ್ತಾರೆ. ಓಕೆ,
ತುಂಬಾ ಬಿಸಿನೀರಿದೆ. ರಿಮೆಂಬರ್ ಸರ್, ಬಿಸಿನೀರಿದೆ ಸರ್.
ಬಿಸಿನೀರಿದೆ, ಹಾಕಿ. ಬಿಸಿನೀರನ್ನ ಹಾಕ್ಬಿಟ್ಟು ಸ್ವಲ್ಪ ಈ ಥರ ಅಲ್ಲಾಡಿಸ್ತಾರೆ. ಓಕೆ, ಅಲ್ಲಾಡಿಸ್ಬಿಟ್ಟು ಬಿಸಾಕ್ಬಿಡ್ತಾರೆ. ಅಲ್ಲಾಡಿಸಿ, ಸ್ವಲ್ಪ ಅಲ್ಲಾಡಿಸಿ, ಚೆನ್ನಾಗಿ ಅಲ್ಲಾಡಿಸಿ. ಹಾಂ, ಇಲ್ಲ ಬೇಡ ಕ್ಯಾಪ್ ಹಾಕ್ಬೇಡಿ, ಕ್ಯಾಪ್ ಹಾಕ್ಬಾರ್ದು. ಹಾಂ, ಬಿಸಿನೀರು. ಓಕೆ, ಬಿಸಿನೀರು ಅಲ್ಲಾಡಿಸ್ತಾ ಇದ್ದೀವಿ. ಓಕೆ, ನಾವು ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪುಟ್ ದ ಕ್ಯಾಪ್ ಆನ್, ರೈಟ್? ಓಕೆ, ಪುಟ್ ದ ಕ್ಯಾಪ್ ಆನ್ ಫಾಸ್ಟ್. ಓಕೆ, ಲೆಟ್ ಸಿ. ಜಸ್ಟ್ ವೇಟ್ ಅ ಫ್ಯೂ ಮಿನಿಟ್ಸ್. ಓಕೆ, ಏನು ಆಗ್ತಾ ಇದೆಯೋ ಅದನ್ನ ನೀವು ಹೇಳಬೇಕು. ಓಕೆ, ಯು ಹ್ಯಾವ್ ಟು ಎಕ್ಸ್ಪ್ಲೇನ್. ಕ್ಯಾನ್ ಯು ಸಿ ಸಮ್ ಚೇಂಜ್ ಇನ್ ದ ಶೇಪ್? ವಾಟ್ ಚೇಂಜ್ ಇಸ್ ಹ್ಯಾಪನಿಂಗ್? ಏನಾಗ್ತಾ ಇದೆ? ಶ್ರಿಂಕ್ ಆಗ್ತಾ ಇದೆ. ಕ್ಯಾನ್ ಯು ಸಿ ಇಟ್? ಒಳಗಡೆ ಏನಿತ್ತು? ಬಿಸಿ ಏರ್ ಇತ್ತಾ, ಕೋಲ್ಡ್ ಏರ್ ಇತ್ತಾ? ಹಾಟ್ ಏರ್ ಇತ್ತು. ಹಾಟ್ ಏರ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗುತ್ತಾ, ಕಂಪ್ರೆಸ್ ಆಗುತ್ತಾ? ಇದು ಯಾಕೆ ಕಂಪ್ರೆಸ್ ಆಗ್ತಾ ಇದೆ? ಹಾಟ್ ಏರ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗಬೇಕು ಅಂದರೆ ಇದು ಯಾಕೆ ಕಂಪ್ರೆಸ್ ಆಗ್ತಾ ಇದೆ? ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗಬೇಕಾಗಿತ್ತಲ್ಲ. ವಾಟ್ ಈಸ್ ಹ್ಯಾಪನಿಂಗ್ ಹಿಯರ್? ವೈ ಡಿಡ್ ಇಟ್ ಗೆಟ್ ಕ್ರಶ್ಡ್? ಕಮ್ ಆನ್, ಎಕ್ಸ್ಪ್ಲೇನ್. ನೋಡಿ, ಇನ್ನೂ ಕ್ರಶ್ ಆಗ್ತಾ ಇದೆ. ಒಳಗಡೆ ಬರ್ತಾ ಇದೆಯಾ? ನಾವು ಸೀಲ್ ಮಾಡಿದ್ದೀವಿ ನೋಡಿ. ಯಾಕೆ ಬರಬೇಕು? ಚಳಿಗಾಳಿ ಯಾಕೆ ಒಳಗಡೆ ಬರಬೇಕು? ಬಟ್ ಒಳಗಡೆ ಬರೋಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ವಲ್ಲ, ಆದ್ರೂ ಇದು ಕ್ರಶ್ ಆಗ್ತಾ ಇದೆ. ಇದು ಫುಲ್ಲಿ ಸೀಲ್ಡ್ ಆಗಿದೆ. ದಟ್ ಈಸ್ ವೇರ್ ದ ಆನ್ಸರ್ ಇಸ್ ಏರ್ ಪ್ರೆಷರ್. ಓಕೆ, ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಮಚ್ ಟೈಮ್, ಸೊ ವಿ ಕೆನಾಟ್ ಗೋ ಡೀಪರ್ ಇನ್ ಟು ದ ಕ್ವೆಶನ್ಸ್. ಲೆಟ್ ಮಿ ಜಸ್ಟ್ ಗಿವ್ ಯು ದ ಎಕ್ಸ್ಪ್ಲನೇಷನ್. ಓಕೆ, ಇದು ನಾವು ಬಿಸಿನೀರು ಹಾಕಿದ್ವಿ, ಬಿಸಿನೀರು ಹಾಕಿ ಅದನ್ನು ಬಿಸಾಕ್ಬಿಟ್ವಿ, ರೈಟ್? ಆವಾಗ ಏನಾಯಿತು? ಒಳಗಡೆ ಏರ್ ಬಿಸಿ ಆಯಿತು. ಒಳಗಡೆ ಏರ್ ಬಿಸಿ ಆದಾಗ ನೀವು ಕಾಫಿ ಕುಡಿತಾ ಇರ್ತೀರಲ್ಲ, ಇಲ್ಲ ಟೀ ಕುಡಿತಾ ಇರ್ತೀರಲ್ಲ, ಅದನ್ನ ಟೀ ಕಪ್ನ, ಕಾಫಿ ಕಪ್ನ ಹಾಗೆ ಇಟ್ಟರೆ ಟೀ ಕಾಫಿ ಹಾಗೆ ಬಿಸಿ ಇರುತ್ತಾ? ಇಲ್ಲ ಅಲ್ವಾ? ಏನಾಗುತ್ತೆ? ಅದು ತಣ್ಣಗಾಗುತ್ತೆ ತಾನೆ. ಈ ಏರ್ ಕೂಡ ತಣ್ಣಗಾಗುತ್ತೆ ತಾನೆ. ಒಳಗಡೆ ಇರೋ ಹೀಟು ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ. ಓಕೆ, ಇವಾಗ ಕ್ವಶನ್ ಏನು ಅಂದರೆ, ಇವಾಗ ಮಧ್ಯದಲ್ಲಿ ಬ್ಲೋ ಮಾಡಿದರೆ ಆ ಪೇಪರ್ಸ್ ಇದೆಯಲ್ಲ, ಅದು ದೂರ ಹೋಗುತ್ತಾ, ಹತ್ರ ಬರುತ್ತಾ? ಯಾರು ಹೇಳ್ತಾ ಇದಾರೆ ಹತ್ರ ಬರುತ್ತೆ ಅವ್ರಿಗೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕು ಯಾಕೆ ಹತ್ರ ಬರ್ತಾ ಇದೆ. ಯಾರು ಹೇಳ್ತಾ ಇದಾರೆ ದೂರ ಹೋಗ್ತಾ ಇದೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಕೂಡ ಮಾಡಬೇಕು. ಓಕೆ, ಕಮ್ ಹಿಯರ್.
ತಪ್ಪಿಗೆ ಆನ್ಸರ್
ನೀವು ಬನ್ನಿ.
ಕರೆಕ್ಟ್ ಆನ್ಸರ್ ಬೇಕು.
ಕಮ್ ಹಿಯರ್.
ಆನ್ಸರ್ಸ್ ಬೇಕು.
ಯು ಕಮ್ ಹಿಯರ್ ಬನ್ನಿ. ಕಮ್ ಹಿಯರ್. ನೀವು ಹೇಳಿದ್ರಲ್ಲ ಹತ್ರ ಬರುತ್ತೆ ಅಂತ. ಓಕೆ, ವಿ ವಿಲ್ ಫಸ್ಟ್ ಸಿ ಏನಾಗುತ್ತೆ ಅಂತ. ಸೊ ಬ್ಲೋ ಮಾಡಿ. ಏನಾಯ್ತು?
ಹತ್ರ ಬಂದು
ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? ಸರಿಯಾಗಿ ತೋರಿಸಿ ಅವ್ರಿಗೆ. ಹತ್ರ ಬಂತು ದೂರ ಹೋಯ್ತಾ? ಹತ್ರ ಬಂತು. ಆ ಕಡೆ ತೋರಿಸಿ. ಅಲ್ಲ, ಈಗ ಟರ್ನ್ ಆಗಿ ರೊಟೇಷನ್ ಡಿಗ್ರಿ ಅವರು ಹೇಳಿದ್ರಲ್ಲ, ರೊಟೇಷನಲ್ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಅಂತ. ಟರ್ನ್ ಆಗಬೇಕು. ಅಲ್ಲಿಗೆ ತೋರಿಸಿ. ಹತ್ರ ಬಂತಾ ದೂರ ಹೋಯ್ತಾ? ಹತ್ರ ಬಂತು. ಓಕೆ, ಸೊ ಇವಾಗ ಅವರು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾರೆ, ತಗೊಳ್ಳಿ. ಎಸ್ ಕನ್ನಡ, ಸಂಸ್ಕೃತ್, ಹಿಂದಿ, ತಮಿಳ್, ಮಲಯಾಳಂ, ಎನಿಥಿಂಗ್. ಗೋ ಹೆಡ್. ಹೇಳಿ. ಇಲ್ಲ, ನಮ್ ಫಸ್ಟ್ ಅಲ್ಲ, ಅವ್ರಿಗೆ ಹೇಳ್ಬೇಕು ನೀವು. ಹೇಳಿ.
ರಾಂಗ್ ಆನ್ಸರ್ ಬೇಕು.
ರಾಂಗ್ ಆನ್ಸರ್ ಇರಲಿ. ನೀವು ಆನ್ಸರ್ ಹೇಳ್ಬೇಕು ಅಷ್ಟೇ. ಗೋ ಹೆಡ್.
ವಿ ವಾಂಟ್ ರಾಂಗ್ ಆನ್ಸರ್.
ನೀವು ಏನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ರೆ ಡಾಕ್ಟರ್ ಪತ್ತರ್ ಫಸ್ಟ್ ಹೇಳಿದ್ರಲ್ಲ, ಅದರಿಂದ ಕನೆಕ್ಟ್ ಮಾಡ್ಬೇಕು ನೀವು ಅಷ್ಟೇ.
ಹೇಳಿ, ಏನ್ರ ಹೇಳು.
ಅವರು ಏನು ಹೇಳಿದ್ರಲ್ಲ, ಪೇಪರ್ ಮೇಲ್ಗಡೆ ಯಾಕೆ ಬರ್ತಾ ಇದೆ ಅಂತ, ಆಮೇಲೆ ನಾನೊಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ತೋರಿಸಿದ್ನಲ್ಲ, ಅದರಿಂದ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕು. ಗೋ ಹೆಡ್.
ಎರಡು ವಸ್ತುಗಳ ಮುಖಾಂತರ ನಡುವರಿ ನಾವು ಪ್ರೆಷರ್ ಹಾಕಿದಾಗ ಏನಾಗ್ತದೆ, ಎರಡು ವಸ್ತುಗಳು ದೂರ ಹೋಗೋದಕ್ಕಿಂತ ಒತ್ತಡ ಆಗಿ ಕೂಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ.
ಯಾಕೆ
ಅಂದ್ರೆ ಏರ್ ಪ್ರೆಷರ್ ನಾವು ನಡುವೆ ಕೊಟ್ಟಾರಿದ್ದು ಅಂದ್ರೆ ಬೇರೆ ಕಡೆ ಹೋಗೋದಿಲ್ಲ. ಅಂದ್ರೆ ಈ ಕಡೆ ಜಗ್ಗಿದ್ರೆ ಒಳಗಡೆ ಈ ತರ ಒಂದ್ ಕಡೆ ಕುಡ್ಸಕ್ ಟ್ರೈ ಮಾಡ್ತಾರೆ.
ನಮ್ಮ ಹತ್ರ ಒಂದು ಪೈಪ್ ಇದೆ. ಓಕೆ, ಇದು ಯಾವುದರಿಂದ ಮಾಡಿರೋದು? ಕಾಪರ್ ಪೈಪ್. ವೆರಿ ಗುಡ್. ಸೊ ಆಲ್ ಆಫ್ ಯು ಕ್ಯಾನ್ ಸಿ ಇಟ್ಸ್ ಅ ಕಾಪರ್ ಪೈಪ್. ಹೋಲ್ಡ್ ಮಾಡಿ. ಇಸ್ ಇಟ್ ಹೆವಿ? It's little bit heavy, right? Okay. Now the next question, is copper magnetic? See, there are only two answers, yes or no. Okay. If it is no, it's a yes. If it's a yes, if it is not a yes, it's a no, right? So tell me finally, what's your final answer? Is copper magnetic? No? Your answer? I'll not be ilhele. No. Okay. Copper is not magnetic. Okay. We can see that. So let's check. We can check by, where is the magnet? Here. Yeah.
It's a very strong magnet.
So it's a very strong magnet, right? You can see this. So, camera ತೋರಿಸ್ಬಿಡಿ.
ಕಾಣಿಸ್ತಾ ಇದೆನಾ ಅಲ್ಲಿ ಮಾನಿಟರ್ ಅಲ್ಲಿ? Can you see this?
ಅದಕ್ಕೆ ತೋರಿಸ್ಬಿಡಿ.
ಓಕೆ, ಇದು ನಾನ್ ಮ್ಯಾಗ್ನೆಟ್. ಇದೇನಿದೆ, ಇದು ಸ್ಟೀಲ್ ಐರನ್ ಬಾಲ್ ಇದು. ಓಕೆ, ಇವಾಗ ನೋಡಿ, ಇದು ಮ್ಯಾಗ್ನೆಟ್. ಇದಕ್ಕೆ ND ಮ್ಯಾಗ್ನೆಟ್ ಅಂತೀವಿ. ND ಅಂತಂದ್ರೆ ನ್ಯೂಟನಿಯನ್ ಮ್ಯಾಗ್ನೆಟ್ ಆರ್ ರೇರ್ ಅರ್ತ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ವೆರಿ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟ್. ಇಟ್ ಈಸ್ ಅವೈಲೇಬಲ್ ಇನ್ ಅಮೆಝಾನ್. ಅಮೆಝಾನ್ ಅಂದ್ರೆ ಅಮೆಝಾನ್ ಕಾರ್ಡ್ ಅಲ್ಲ, amazon.in ಅಲ್ಲಿ. ಓಕೆ, ಈ ಥರ ನೋಡಿ ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ ನೋಡಿ. ವೆರಿ ಸ್ಟ್ರಾಂಗ್ ಮ್ಯಾಗ್ನೆಟ್, ವೆರಿ ಸ್ಟ್ರಾಂಗ್. ಇದನ್ನ ಸಪ್ರೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಈಗ ಸ್ಲೈಸ್ ಮಾಡಿ ತೆಗಿಬೇಕಿದೆ ಬಟನ್.
ಓಕೆ,
ಇದು ಕಾಪರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲ ಅಂತ ತೋರಿಸ್ತಾ ಇದೆ
ನೋಡಿ. ಕಾಪರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲ. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಸಿ ಕಾಪರ್ ಇಸ್ ನಾಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್, ರೈಟ್? ಇಟ್ ಇಸ್ ನಾಟ್ ಸ್ಟಿಕ್ಕಿಂಗ್. ದಟ್ಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಸಿ. ಫೈನ್. ಸೊ ನೌ ಲೆಟ್ಸ್ ಡೂ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಓಕೆ, ಹೋಲ್ಡ್ ದಿಸ್. ಸೊ ನಾವು ಒಂದು ಡ್ರಾಪ್ ಮಾಡ್ತೀವಿ ಇದನ್ನ ನೋಡಿ.
ನೀವು ಇಲ್ಲಿ ಕೆಳಗಡೆ ನೀವು ಫೋಕಸ್ ಮಾಡಿ, ಅವ್ರಿಗೆ ಕಾಣಿಸ್ಬೇಕು. ನಾವು ಈ ಕಡೆಯಿಂದ ಮಾಡೋಣ, ಯಾಕಂದ್ರೆ ನೋಡಕ್ಕೆ ಅವ್ರಿಗೆ.
ಓಕೆ, ಇಲ್ಲಿ ಬನ್ನಿ. ಸ್ವಲ್ಪ ಮೇಲ್ಗಡೆ ಇಟ್ಕೊಳ್ಳಿ. ನೀವು ಬನ್ನಿ, ಇಲ್ಲಿ
ಕಾಣಿಸ್ತಾ ಇದೆ ಎಲ್ರಿಗೂ?
ಓಕೆ, ಅವ್ರು ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಇದನ್ನು ಹೋಲ್ಡ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ನಾವು ಮೇಲ್ಗಡೆಯಿಂದ ಡ್ರಾಪ್ ಮಾಡ್ತೀವಿ. ಮೇಲ್ಗಡೆಯಿಂದ ಒಂದು ಐರನ್ ಪೀಸ್ ಡ್ರಾಪ್ ಮಾಡ್ತೀವಿ.
ಕೌಂಟ್ ಮಾಡಿ ಎಷ್ಟಾಗುತ್ತೆ ಅಂತ, ಅದು ಕೆಳಗಡೆ ಬಂದು ರೀಚ್ ಆಗಕ್ಕೆ
ನೀವು ಹೋಲ್ಡ್ ಮಾಡ್ಬೇಕು. ಕೆಳಗಡೆ ಹಿಡ್ಕೋಬೇಕು ಅದು ಬಂದಾಗ. ಓಕೆ, ಸೊ 1 2 3 ಮಾಡಿದಾಗ 3 ಅಟ್ ದ ಕೌಂಟ್ ಆಫ್ 3 ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡ್ರಾಪ್ ಇಟ್. ಓಕೆ, ನೀವು ಹೇಳಬೇಕು ಎಷ್ಟು ಟೈಮ್ ಆಯಿತು ಅಂತ. ಸ್ವಲ್ಪ ಕೆಳಗಡೆ ಹಿಡ್ಕೋಬೇಕು, ಕಾಣಿಸ್ಬೇಕಲ್ಲ. ಅಲ್ಲ, ನೀವು ಮೇಲ್ಗಡೆ ಇಟ್ಕೊಳ್ಳಿ, ನೀವು ಕೆಳಗಡೆ ಇಟ್ಕೋಬೇಕು ಸ್ವಲ್ಪ ದೂರ. ಓಕೆ, 1 2 3. ಎಷ್ಟೊತ್ತು ತಗೊಳ್ತು? ಲೆಸ್ ದೆನ್ 1 ಸೆಕೆಂಡ್. ಓಕೆ, ಆಲ್ಮೋಸ್ಟ್ ಹಾಫ್ ಅ ಸೆಕೆಂಡ್. ಒನ್ ಮೋರ್ ಟೈಮ್. ನೀವು ಕೂತ್ಕೊಂಡೇ ಇರ್ಬೇಕಲ್ಲಿ. ಓಕೆ, 1 2 3, half a second. Okay, so now we'll drop magnets. Adu non magnetic ittu. Okay, now we are dropping magnets. Esto tagolto? Nearly 5 seconds. Okay, this was a magnet. Copper is magnetic or non-magnetic? Non-magnetic. Okay, non-magnetic, remember, but it is taking 5 seconds. Even more than 5 seconds. Almost 7 seconds. See now, this experiment is a little bit strange because I am using electric power to power the blower. Okay, electric power in the electric power produce ಮಾಡ್ತಾ ಇದೀವಿ. But the idea is to show that purely using the air, flowing air, right? High speed wind. ಅದರಿಂದ ನಾವು ಫ್ಯಾನ್ ರನ್ ಮಾಡ್ತಾ ಇದೀವಿ, ರೈಟ್? ಆ ಫ್ಯಾನ್ ರನ್ ಮಾಡ್ತಾ ಇರುವಾಗ ಒಳಗಡೆ ಒಂದು ಮೋಟರ್ ಇದೆ. ಸೊ ದ ಮೋಟರ್ ಇಸ್ ಆಕ್ಚುಲಿ ರನ್ನಿಂಗ್ ಇನ್ ರಿವರ್ಸ್ and becoming a generator, right? So the same thing, if you supply electric power, it gets converted to mechanical energy. But if you supply mechanical energy, you can produce electrical energy with the same device. Okay?
Example, ಲಿಕ್ವಿಡ್ ನೀವು ಏನಾದರೂ ಕೈ ಇಟ್ರಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, more than 10 seconds, if you try to take out your hand, ಹೀಗೆ ಮಾಡ್ಬಿಟ್ರೆ ಕೆಳಗಡೆ ಹೋಗ್ಬಿಡುತ್ತೆ ಕೈ. ಕಟ್ಟಾಗ್ಬಿಡುತ್ತೆ. ನಿಜವಾಗ್ಲೂ. Okay? If you try to
ವಿನಾಯಕ್, ನೀವು ತೋರಿಸ್ಬೇಕು ಅದನ್ನ. ನೀವು ತೋರಿಸ್ತೀರಾ? ನೋಡಿ ತೋರಿಸ್ತಾರೆ ಇವಾಗ.
ನೋಡಿ ಸರ್, ಹಿಂದ್ಗಡೆ ಲೇಡೀಸ್
ಅವ್ರ ಕೈ ಬಿದ್ದೋಗ್ಬಿಡುತ್ತೆ.
ವಿಶ್ ಮಾಡಿದ್ದೀನಿ, ಅವ್ರು ನೋಡಿದ್ರೆ ನನ್ನ ಕೈ ಮೇಲೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ಓಕೆ,
ನೋಡಿ ವಿನಾಯಕ್ ತೋರಿಸ್ತಾರೆ ಇವಾಗ ನೋಡಿ.
ಡೋಂಟ್ ಪ್ಲೇ ವಿತ್ ದ ಲಿಕ್ವಿಡ್ ಹೈಡ್ರೋಜನ್. ಬಹಳ ಡೆಡ್ಲಿ ಇದು. ಯಾಕಂದ್ರೆ ಇದನ್ನ ಕೈ ಇಟ್ಕೊಂಡ್ಬಿಟ್ರೆ ಕೋಲ್ಡ್ ಬರ್ನ್ ಆಗುತ್ತೆ, ಆರ್ ಫ್ರಾಸ್ಟ್ ಬೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈಗ ಹೇಗೆ ಬರ್ನ್ ಆಗಿರುತ್ತಲ್ಲ, ಬೆಂಕಿ ಸುಟ್ಕೊಂಡಿರ್ತಾರಲ್ಲ, ಅದೇ ತರನೇ ಅದಕ್ಕೆ ಗಾಯ ಆಗುತ್ತೆ. ಓಕೆ, 15 days ಇಂದ 20 days ಬೇಕು ಅದನ್ನ ಯೂಸ್ ಮಾಡಕ್ಕೆ. ಐ ಹ್ಯಾವ್ a flower here. ಆ ಫ್ಲವರಿಗೆ ಒಂದ್ಸರಿ ಸಾರಿ ಕೇಳ್ಬಿಡಿ ಎಲ್ಲರೂ. ಅದೇ ನಿಮ್ದು ಕೈ ಎಳ್ಕೊಂಡ್ಬಿಡಿ, ನಿಮ್ದಲ್ಲ ಯಾವ್ದಾರ ಬೇರೆ ಒಂದು. ಓಕೆ, ಐ ಜಸ್ಟ್ ಪೂರ್ ದ ಲಿಕ್ವಿಡ್ ಹೈಡ್ರೋಜನ್. ನೋಡಿ ಬರೀ 10 seconds. ಕ್ಯಾನ್ ಯು ಕೌಂಟ್ 1 to 10? 1 2 3 ಸ್ಟಾರ್ಟ್ ಕೌಂಟಿಂಗ್. 5 6 7 8 9 10. Okay, you can press it, sir. See?
Okay.
ಇದು ಕೈ ಎತ್ಕೊಳ್ಳಿ, ನೋಡಿ ಏನಾಯ್ತು.
This is what will happen to your hand. Okay? So be very, very careful.
-196 degrees Celsius ಅದ್ರ ಬಾಯ್ಲಿಂಗ್ ಟೆಂಪರೇಚರ್ ಬಂದು. ಓಕೆ, -196. ಎಷ್ಟು ಸರಿ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಆಗುತ್ತೆ? 700 ಟೈಮ್ಸು. ಇವಾಗ ಏನಾದರೂ ನೀನು ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನಲ್ಲಿ ಕೈ, ಎಕ್ಸಾಂಪಲ್ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನಲ್ಲಿ ನೀವೇನಾದರೂ ಕೈ ಇಟ್ರಿ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, more than 10 seconds, if you try to take out your hand, ಹಿಂಗೆ ಮಾಡಿಬಿಟ್ರೆ ಕೆಳಗಡೆ ಬಿದ್ದೋಗ್ಬಿಡುತ್ತೆ, ಕೈ ಕಟ್ಟೆ ಆಗ್ಬಿಡುತ್ತೆ ನಿಜವಾಗ್ಲು. ಓಕೆ, ಇಫ್ ಯು ಟ್ರೈ ಟು ಹೋಲ್ಡ್ ಇಟ್ ಬಿಕಾಸ್ ಯು ವಾಂಟ್ ಟು ಸೀ ದಟ್ ಸರ್, ಅಲ್ಲಿ ನೋಡಿ ಸರ್, ಹಿಂದ್ಗಡೆದವ್ರು ಲೇಡೀಸ್ ಇವತ್ತು ವುಮೆನ್ಸ್ ಡೇ ಅಂತ ನಾ ವಿಶ್ ಮಾಡಿದ್ದೀನಿ, ಅವ್ರು ನೋಡಿದ್ರೆ ನನ್ನ ಕೈ ಮೇಲೆ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೇಕಂತ. ಓಕೆ, ಫೈನ್. ಸಿ ಡೋಂಟ್ ಥಿಂಕ್, ಡೋಂಟ್ ಪ್ಲೇ ವಿತ್ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್. ಭಾಳ ಡೆಡ್ಲಿ ಇದು. ಯಾಕಂದ್ರೆ ಇದನ್ನ ಕೈಲಿ ಇಟ್ಕೊಂಡ್ಬಿಟ್ರೆ ಕೋಲ್ಡ್ ಬರ್ನ್ ಆಗುತ್ತೆ, ಆರ್ ಫ್ರಾಸ್ಟ್ ಬೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಈಗ ನಿಮ್ಗೆ ಹೇಗೆ ಬರ್ನ್ ಆಗಿರುತ್ತಲ್ಲ, ಬೆಂಕಿಲಿ ಸುಟ್ಕೊಂಡಿರ್ತಾರಲ್ಲ, ಅದೇ ಥರನೇ ಅದಕ್ಕೆ ಗಾಯ ಆಗುತ್ತೆ. ಓಕೆ, 15 days ಇಂದ 20 days ಬೇಕಾದ್ರೆ ಇದನ್ನ ಮಾಡೋಕ್ಕೆ. ಐ ಹ್ಯಾವ್ ಅ ಫ್ಲವರ್ ಹಿಯರ್. ಆ ಫ್ಲವರಿಗೆ ಒಂದು ಸರಿ ಸಾರಿ ಕೇಳ್ಬಿಡಿ ಎಲ್ಲರೂ. ಅದೇ ನಿಮ್ಮದು ಕೈ ಅನ್ಕೊಂಬಿಡಿ, ನಿಮ್ದಲ್ಲ ಯಾವ್ದಾರ ಬೇರೆ ಒಂದು ಇದು. ಓಕೆ, ಐ ಜಸ್ಟ್ ಪೂರ್ ದ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್. ನೋಡಿ ಬರೀ 10 seconds. ಕ್ಯಾನ್ ಯು ಕೌಂಟ್ 1 to 10? 1 2 3 ಸ್ಟಾರ್ಟ್ ಕೌಂಟಿಂಗ್. 5 6 7 8 9 10. ಓಕೆ, ಯು ಕ್ಯಾನ್ ಕ್ರಶ್ ಇಟ್ ಸರ್. ಸಿ, ಈ ಕಡೆ.
ಓಕೆ,
ಇದು ಕೈ ಅನ್ಕೊಳ್ಳಿ, ನೋಡಿ ಏನಾಯ್ತು.
This is what will happen to your hand. Okay?
Okay, one more time I'll show you. ಇದ ಕೊಡಿ ಸರ್. It's a very dangerous. You cannot hold the liquid nitrogen and carry. ಇದನ್ನ ಈ ತರ ಹಿಂಗೆ ಹಿಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಎಲ್ಲಿ ಹೋಗಬಾರ್ದು. By mistake I took it. Okay. Okay. See, ಯಾಕೆ ಇದನ್ನೆಲ್ಲ ನಿಮಗೆ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ ಮಿಸ್ಟೇಕ್ ಮಾಡಿ ಅಂತ. You are not supposed to do any mistakes because it is dangerous. It expands 700 times. You can make a bomb out of it.
Only scientists can make.
Okay? Yeah. See? Start counting.
1 2 3 4 5 6 7 8 9 10.
Okay. ನೋಡಿ ಹೇಗಾಗುತ್ತೆ ಇಲ್ಲಿ. ಗ್ಲಾಸ್ ಥರ ಆಗ್ಬಿಡ್ತದು. ಓಕೆ, ಫೈನ್. Don't play with this. I'll just show you Ellen to this experiment, superconductivity experiment. And remember, you must wear a safety glasses. Huh?
ಸೊ ಅವ್ರು ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಇದೆಲ್ಲ -200 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಹೇಳಿದ್ರು. ದ್ಯಾಟ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಬೀಯಿಂಗ್ ಯೂಸ್ ಟು ಕೂಲ್ ದಟ್ ಮೆಟೀರಿಯಲ್. YBCO ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, ಅದನ್ನು ಅವರು ಕೂಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಓಕೆ, ಯಾಕೆ ಕೂಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಅದ್ರ ಒಳಗಡೆ ಬೋಸ್ ಐನ್ಸ್ಟೈನ್ ಕಂಡೆನ್ಸೇಷನ್ ಆಗಬೇಕು ಅಂತ. ಓಕೆ, ಸೊ ದಟ್ ದೆರ್ ಇಸ್ ಅ ಬ್ಲ್ಯಾಕ್ ಮೆಟೀರಿಯಲ್ ಹಿಯರ್. ಲೇಟರ್ ಆನ್ ವೆನ್ ದಿಸ್ ಇಸ್ ಓವರ್ ಯು ಕ್ಯಾನ್ ಕಮ್ ಅಂಡ್ ಸಿ ದಿಸ್. ಒಂಥರ ಬ್ಲ್ಯಾಕ್ ಸೆರಾಮಿಕ್ ಥರ ಮೆಟೀರಿಯಲ್ ಇದೆ. ದ್ಯಾಟ್ ಬ್ಲ್ಯಾಕ್ ಸೆರಾಮಿಕ್ ಲೈಕ್ ಮೆಟೀರಿಯಲ್ ಇಸ್ ಬೀಯಿಂಗ್ ಕೂಲ್ಡ್ ಬಿಲೋ ಇಟ್ಸ್ ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್. ಇವಾಗ ವಾಟರ್ಗೆ ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್ ಫ್ರಮ್ ಲಿಕ್ವಿಡ್ ಟು ಸ್ಟೀಮ್ ಇಸ್ 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. ಬಟ್ ಫಾರ್ ದಿಸ್ ಮೆಟೀರಿಯಲ್ YBCO, the transition temperature from normal phase to superconducting phase is around 90 Kelvin. Okay, for liquid nitrogen to boil it is 77 Kelvin. So ನಾವು ಆ ಮೆಟೀರಿಯಲ್ ನ ಅದರದ್ದು ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್ ಇಂದ ಇನ್ನೂ ಕೆಳಗಡೆ ಕೂಲ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಕೂಲ್ ಮಾಡಿದಾಗ ಅದು ಬೋಸ್ ಐನ್ಸ್ಟೈನ್ ಕಂಡೆನ್ಸೇಟ್ ಫೇಸ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ. That's the fifth state of matter. But how strange is that? That is what you will see now. Okay, when it goes into that superconducting state, then what happens? Dr. Patar will tell you now.
You know the conductor, right? Huh? Bus conductor alla. The conductor, the material which conduct the electricity or the heat, ಇವೆಲ್ಲ ಕಂಡಕ್ಟರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ನಾವು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡ್ತಾ ಇರೋದು ಇಲ್ಲಿ ಯಾವ್ದು ಅಂತಂದ್ರೆ the electrical conductor. Electrical conductor take any metal, all are the conductors. ಎಲ್ಲದಕ್ಕೂ ಒಂದೊಂದು ಸ್ವಲ್ಪ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರುತ್ತೆ. ಈಗ ನೋಡಿ, ಒಂದು ವೈರ್ ಇದೆ ಇಲ್ಲಿಂದ. ಕ್ಯಾನ್ ಯು ಸಿ ದ ವೈರ್? ಇಲ್ಲಿಂದ ಬಟನ್ ಆನ್ ಮಾಡಿದೆ, ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ. ಹೌದಾ? ಕರೆಂಟ್ ಇಲ್ಲಿ ನಾನು ಮೆಜರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಎಷ್ಟು ವೋಲ್ಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ? 2 ವೋಲ್ಟ್ ಮೆಜರ್ ಮಾಡಿದ್ದೀನಿ. ಇಲ್ಲಿ ಆ ಪೊಟೆನ್ಷಿಯಲ್ ಎಷ್ಟು ಒನ್ ಮೈಕ್ರೋ ಆಂಪಿಯರ್ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿವರೆಗೂ ಬಂದು ರೀಚ್ ಆಗೋಕ್ಕೆ ನಮಗೆ ಅಷ್ಟು ಕರೆಕ್ಟ್ ಬರೋದಿಲ್ಲ, 2 ವೋಲ್ಟ್ ಸಿಗೋದಿಲ್ಲ ಇಲ್ಲಿ ನಮಗೆ. ಯಾಕಂದ್ರೆ ಡ್ಯೂ ಟು ದ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ದ ವೈರ್ ವಿ ಲೂಸ್ ಅ ಲಾಟ್ ಆಫ್ ದಿ ಪವರ್. ಅದೇ ನೀವು ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ವೈರ್ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿಂದ ಕರೆಂಟ್ ನೀವು ಕೊಟ್ಟರೆ ನೀವು 10-20 ಲಕ್ಷ ಕಿಲೋಮೀಟರ್ ನೀವುವರೆಗೂ ನೀವು 2 ವೋಲ್ಟ್ ಕೊಡಿ, ನೀವು ಅಲ್ಲ 1 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಕೊಡಿ, ಲಾಸ್ಟ್ 20 ಲಕ್ಷ ಕಿಲೋಮೀಟರ್ ಆದ್ಮೇಲೂ ಕೂಡ ಅಷ್ಟೇ ಬರುತ್ತೆ. ಯಾಕಂದ್ರೆ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಅಂತಂದ್ರೆ ಆ ಮಟೀರಿಯಲ್ ರೆಸಿಸ್ಟೆನ್ಸೇ ಇರೋದಿಲ್ಲ. ರೆಸಿಸ್ಟೆನ್ಸ್ ಜೀರೋ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮಟೀರಿಯಲ್. ಅದಕ್ಕೆ ನಾವು ಸೂಪರ್ ಕಂಡಕ್ಟರ್, ಸೂಪರ್ ಅನ್ನೋ ವರ್ಡ್ನ ಆ್ಯಡ್ ಮಾಡಿಬಿಟ್ಟು ಅದಕ್ಕೆ. ಹೌದಲ್ವಾ? ಆಮೇಲೆ ಏನೇನಾಗುತ್ತೆ ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಸಾರೆ ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ. ಒಳಗಡೆ ಏನಾಗುತ್ತೆ, ನಾರ್ಮಲಿ ನಮ್ಮ ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ದೇ ಕ್ಯಾನ್ ಕೊಲೈಡ್ ಈಚ್ ಅದರ್, ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರ್ಯಾಂಡಮ್ ಆಗಿ ಈ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ. ದೇ ಕ್ಯಾನ್ ಕೊಲೈಡ್ ಈಚ್ ಅದರ್. ಆದ್ರೆ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಕೂಪರ್ ಪೇರ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರು. ಕೂಪರ್ ಪೇರ್ ಏನ್ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ರ್ಯಾಂಡಮ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ. ಈ ಸೂಪರ್ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಪೇರ್ ಆಗ್ಬಿಟ್ಟು ಮೂವ್ ಆಗುತ್ತೆ. ನಾನು ಪೇರ್ ಆಗೋಣ, ಆರಾಮಾಗಿ ಹೋಗೋಣ ಅಂತ. ಅದು ದೇರ್ ಇಸ್ ಸೈನ್ಸ್ ಬಿಹೈಂಡ್ ಇಟ್. ಆಲ್ರೆಡಿ ಹಿ ಹ್ಯಾಸ್ ಎಕ್ಸ್ಪ್ಲೈನ್. ದೇ ಪೇರ್ ಅಪ್ ಅಂಡ್ ದೇ ಮೂವ್ ಇಟ್. ಅವಾಗ ರೆಸಿಸ್ಟೆನ್ಸೇ ಇರೋದಿಲ್ಲ. ಯು ಆರ್ ಗೆಟಿಂಗ್ ಮೈ ಪಾಯಿಂಟ್? ಓಕೆ, ಇನ್ನು ಬೇರೆ ಬೇರೆ ಕಂಡೀಷನ್ಸ್ ಇದೆ, ಅದು ಹೇಗೆ ಸೂಪರ್ ಕಂಡಕ್ಟಿಂಗ್ ಸ್ಟೇಟಿಗೆ ಹೋಗುತ್ತೆ ಅಂತ. ವಿ ಡೋಂಟ್ ಹ್ಯಾವ್ ಟೈಮ್. ಓಕೆ, ಫೈನ್. ಈಗ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಅಲ್ಲಿ ಇತ್ತು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಅದು ಏನಿಲ್ಲ, ಒಂಥರ ಸಿರಾಮಿಕ್ ಡಿಸ್ ತರ ಕಲ್ಲಿದ್ದಂಗೆ. ಯಾವಾಗ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಟೆಂಪರೇಚರ್ ತಗೊಂಡು ಹೋಗ್ತೀವಿ, ಸೈಂಟಿಸ್ಟ್ ಆ ಒಂದು ಟೆಂಪರೇಚರ್ಗೆ ಕಂಡು ಹಿಡಿದಿದ್ದಾರೆ. ಇನ್ನು ಬೇರೆ ಬೇರೆ ಟೆಂಪರೇಚರಲ್ಲೂ ಕಂಡು ಹಿಡಿದಾರೆ ಬೇರೆ ಬೇರೆ ಮೆಟೀರಿಯಲ್ಸ್. ನನ್ನ ಹತ್ರ ಇರೋ ಮೆಟೀರಿಯಲ್ ಎಟ್ರಿಯಂ, ಬೇರಿಯಂ, ಕಾಪರ್ ಆಕ್ಸೈಡ್. ಆ ಒಂದು ಈ ಪಿರಿಯಡ್ ಟೇಬಲ್ ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ನ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಅದನ್ನೆಲ್ಲ ಮಿಕ್ಸ್ ಮಾಡಿಬಿಟ್ಟು ಈ ಥರ ಮಾಡಿದ್ದಾರೆ. ದಟ್ ಇಸ್ ಸೂಪರ್ ಕಂಡಕ್ಟರ್. ಆದರೆ ಇದು ವರ್ಕ್ ಆಗೋದು ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಟೆಂಪರೇಚರಲ್ಲಿ, ರೂಮ್ ಟೆಂಪರೇಚರಲ್ಲಿ ವರ್ಕ್ ಆಗಲ್ಲ. ಇದನ್ನ ಪಾಸಿಟಿವ್ ಎಷ್ಟು ನನ್ನ ಹತ್ರ ಅಲ್ಲಿ ಕಿಟಲಿದೆ, ಆಲ್ಮೋಸ್ಟ್ ಒಂದು 80 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಪಾಸಿಟಿವ್ ಅಲ್ಲಿದೆ, ಕುದೀತಾ ಇದೆ ನೀರು. -196ನ ಕುದಿಯೋ ನೀರಿಗೆ ಹಾಕ್ಬಿಟ್ರೆ ಏನಾಗುತ್ತೆ, ಇವಾಪರೇಷನ್ ರೇಟ್ ಏನಾಗುತ್ತೆ, ಫಾಸ್ಟ್ ಆಗುತ್ತೆ. ತುಂಬ ಫಾಸ್ಟ್ ಇವಾಪರೇಟ್ ಆಗೋಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆದ ತಕ್ಷಣ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ರೇಟ್ನು ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಇವಾಪರೇಷನ್ ದಟ್ ಇಸ್ ಸೇಮ್ ಥಿಂಗ್. ಓಕೆ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಜಾಸ್ತಿ ಆ ಡೆನ್ಸ್ ಆಗಿ ಕಾಣಿಸುತ್ತೆ. ಯು ವಿಲ್ ಸಿ ಅದು ಇಟ್ಸ್ ಲುಕ್ಸ್ ಲೈಕ್ ಅ ಕ್ಲೌಡ್ ತರ ಆಗುತ್ತೆ. ಒಂದು ಕ್ಲೌಡ್ ಫಾರ್ಮ್ ಮಾಡೋಣ ಇಲ್ಲಿ. ಟೆಲ್ ಮಿ ಎಸ್ ಆರ್ ನೋ? ಪರ್ಫೆಕ್ಟ್. ಓಕೆ, ನಾವು ವಿಲ್ ಕ್ರಿಯೇಟ್ ಅ ಕ್ಲೌಡ್ ಸರ್.
ಸೊ ಅವ್ರು ಏನು ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಲಿಕ್ವಿಡ್ ನೈಟ್ರೋಜನ್ ಇದೆಲ್ಲ -200 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಹೇಳಿದ್ರು. ದ್ಯಾಟ್ ಈಸ್ ವಾಟ್ ಈಸ್ ಬೀಯಿಂಗ್ ಯೂಸ್ ಟು ಕೂಲ್ ದಟ್ ಮೆಟೀರಿಯಲ್. YBCO ಅಂತ ಹೇಳಿದ್ನಲ್ಲ, ಅದನ್ನು ಅವರು ಕೂಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಓಕೆ, ಯಾಕೆ ಕೂಲ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಅದ್ರ ಒಳಗಡೆ ಬೋಸ್ ಐನ್ಸ್ಟೈನ್ ಕಂಡೆನ್ಸೇಷನ್ ಆಗಬೇಕು ಅಂತ. Okay, so that there is a black material here. Later on when this is over you can come and see this. ಒಂಥರ ಬ್ಲ್ಯಾಕ್ ಸೆರಾಮಿಕ್ ಥರ ಮೆಟೀರಿಯಲ್ ಇದೆ. ದ್ಯಾಟ್ ಬ್ಲ್ಯಾಕ್ ಸೆರಾಮಿಕ್ ಲೈಕ್ ಮೆಟೀರಿಯಲ್ ಇಸ್ ಬೀಯಿಂಗ್ ಕೂಲ್ಡ್ ಬಿಲೋ ಇಟ್ಸ್ ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್. ಇವಾಗ ವಾಟರ್ಗೆ ಟ್ರಾನ್ಸಿಷನ್ ಟೆಂಪರೇಚರ್ ಫ್ರಮ್ ಲಿಕ್ವಿಡ್ ಟು ಸ್ಟೀಮ್ ಇಸ್ 100 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. ಕೇರ್ಫುಲ್. That is not just levitating. There is a quantum lock. Okay, that magnet has actually locked that superconductor.
Train ನೋಡ್ತೀರಾ? Japan train, magnetic levitation train by using the superconductor. I'll show you that. ಈಗ ಆಟ ಶುರು actually. Okay, you can see it is levitating. Can you see now? ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಕಾಣಿಸುತ್ತೆ ನೋಡಿ. Okay, levitate ಆಗ್ತದೆ ಅಲ್ವಾ? Okay, ಅಲ್ಲಿ ನೋಡಿ ಮೇಲ್ಗಡೆ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ. ಈಗ ಶೇಕ್ ಮಾಡಿದ್ರು ಬಿಡಲ್ಲ ನೋಡಿ.
ನೋಡಿ ಉಲ್ಟಾ ಮಾಡಿದ್ರು.
ಎಲ್ಲಿವರೆಗೂ ಕೂಲ್ ಇರುತ್ತೆ ಅಲ್ಲಿವರೆಗೂ ಅದು ಪ್ರಾಪರ್ಟಿ ಇದೆ. This is called a magnetic levitation, maglev train concept. Still it is cool. But it's coming to room temperature now. I know at what temperature it will come.
ಟ್ರ್ಯಾಕ್ ಅಂತ ಹೇಳಬೇಕು.
I have a magnetic track here. This is a track. A magnet na ಜೋಡಿಸಿದ್ದೀನಿ ನಾನು. ಆಮೇಲೆ ನೀವು ನೋಡಿ ಮುಗಿದ ತಕ್ಷಣ ಏನು ಟಚ್ ಮಾಡೋಂಗಿಲ್ಲ ಇಲ್ಲಿ ಬಂದಾಗ. I pour liquid nitrogen now. You have to be very careful. ಇಲ್ಲಿ ಫೋಕಸ್ ಮಾಡಿ. Okay? ನಿಮಗೆ ಏನು ಹೇಳಿದೆ? ಕ್ಲೌಡ್ ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ರಲ್ವಾ? ಕೌಂಟ್ ಮಾಡಿ 3 2 1 ಅಂತ ಬಿಸಿ ನೀರು ಹಾಕ್ತೀನಿ. ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿ. ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಕೇರ್ಫುಲ್ ಆಗಿ. ಓಕೆ? ಸ್ಟಾರ್ಟ್. ಓಕೆ 1 ಅಲ್ಲ 3 2 1 3 2 1 ಗೋ.
ವಿನಾಯಕ್ ಬೇಗ ಬೇಗ ಅದು
3 2 1 once more ಅನ್ಬೇಕಿದಕ್ಕೆ ನೀವು. Actually, can you see the path of the light now? No, right? Suppose if you want to see the path of the light, you need a colloidal medium. ಒಂದು ಮೀಡಿಯಂ ಬೇಕು ಅದಕ್ಕೆ. ಆ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಇಷ್ಟೇ ಇರಬೇಕು ಅಂತ ರೂಲು. ಇದಕ್ಕೆ ನೀವು ಟಿಂಡಲ್ ಎಫೆಕ್ಟ್ ಇನ್ನೊಂದು ಅರ್ಥದಲ್ಲಿ ಹೇಳ್ತೀವಿ ದ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಫ್ ಲೈಟ್ ಅಂತಾನು ನಾವು ಇಲ್ಲಿ ಸ್ಕ್ಯಾಟರಿಂಗ್ ಆಫ್ ಲೈಟ್ ನ ಅಬ್ಸರ್ವ್ ಮಾಡಬಹುದು ನಾವು ಇಲ್ಲಿ. ಓಕೆ, ನಾವು ಈ ಅಬ್ಸರ್ವ್ ಕೇರ್ಫುಲಿ. ಇಲ್ಲಿ ಪಾತ್ ಇದೆ, ಪಾತ್ ಕಾಣಿಸ್ತಿಲ್ಲ ಬಿಕಾಸ್ ಲ್ಯಾಕ್ ಆಫ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್, ಡಿಫರೆಂಟ್ ಸೈಜ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್. Now I'm going to create a different size of particle by using the chalk powder. Observe ಮಾಡಿ, ಹೇಗೆ ಕಾಣಿಸುತ್ತೆ ನೋಡಿ. Fan off ಮಾಡಿ, fan. ಈಗ ಲೈಟ್ ಸ್ಟ್ರೈಟ್ ಆಗಿ ಹೋಗ್ತಾ ಇದೆ. ಏನಾದ್ರು ಒಂದು ಚಿಕ್ಕದು ಅಬ್ಸ್ಟಾಕಲ್ ಬಂತು ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ ಲೈಟ್ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಯೂಶುವಲಿ ಡಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಓಕೆ, ತುಂಬಾ ಡೀಟೇಲ್ ಆಗಿ ಐ ಡೋಂಟ್ ವಾಂಟ್ ಟು ಡಿಸ್ಕಸ್ ದಟ್, ಬಟ್ ಡಿಫ್ರಾಕ್ಷನ್ ಆಫ್ ಲೈಟ್ ನ ನೋಡಿ, ಇಟ್ಸ್ ಮೋಸ್ಟ್ ಬ್ಯೂಟಿಫುಲ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ವಿ ಹ್ಯಾವ್ ಅ ಸಿಡಿ ಹಿಯರ್. ಸಿಡಿ ಹ್ಯಾಸ್ ಅ ಮೈಕ್ರೋ ಅಂಡ್ ಮೈಕ್ರೋಕ್ಕಿಂತ ಸ್ವಲ್ಪ ಚಿಕ್ಕದಾಗಿರುತ್ತೆ. ಈ ವೇವ್ ಲೆಂತ್ ಏನಿದೆಯಲ್ಲ, ಲೇಸರ್ ನಾನು ಏನು ಯೂಸ್ ಮಾಡಿದ್ದೀನಿ ಅಂತಂದ್ರೆ, ಕ್ಯಾನ್ ಯು ಹಿಯರ್ ಮಿ ಲಾಸ್ಟ್? ಓಕೆ, ಐ ಹ್ಯಾವ್ ಅ ಲೇಸರ್ ಹಿಯರ್. ಲೇಸರ್ ಹ್ಯಾಸ್ ದ ವೇವ್ ಲೆಂತ್. ಯಾವುದೋ ಒಂದು ಕಲರ್ ಆಫ್ ಲೈಟ್ ಇರಲಿ, ಅದಕ್ಕೊಂದು ವೇವ್ ಲೆಂತ್ ಇರುತ್ತೆ. ಈ ಲೇಸರ್ ವೇವ್ ಲೆಂತ್ ಬಂದು 532 ನ್ಯಾನೋಮೀಟರ್. ಹೌ ಮಚ್? 532 ನ್ಯಾನೋಮೀಟರ್ ಲೇಸರ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ದಟ್ಸ್ ಅ ಗ್ರೀನ್ ಲೇಸರ್. ಓಕೆ, ಆ ವೇವ್ ಲೆಂತ್ 532 ನ್ಯಾನೋಮೀಟರ್ ಇದೆ. ಇಲ್ಲಿ ಟ್ರ್ಯಾಕ್ ಅದಕ್ಕಿಂತ ಚಿಕ್ಕದು, ಇಲ್ಲ ಅದಕ್ಕಿಂತ ಸ್ವಲ್ಪ ದೊಡ್ಡದಾಗಿರ್ಬೇಕು. ಮೈಕ್ರೋ ಟ್ರ್ಯಾಕ್, ವೆರಿ ಸ್ಮಾಲ್ ಟ್ರ್ಯಾಕ್. ಓಕೆ, ಇವಾಗ ಇವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ, ಪ್ರೊಫೆಸರ್ ನೀವು ಥ್ಯಾಂಕ್ ಯು. ವಾಟ್ ಇಸ್ ಯುವರ್ ನೇಮ್? ಓಕೆ, ಮೇರಿಯಾನ್. ಬಿಗ್ ರೌಂಡ್ ಆಫ್ ಅಪ್ಲಾಸ್ ಫಾರ್ ಮೇರಿಯಾನ್. ಥ್ಯಾಂಕ್ ಯು. ಓಕೆ, she is the leader, okay, for this experiment, the scattering of light especially. Now I have a CD here. Sir, ಆ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಟ್ರ್ಯಾಕ್ ಇದೆಯಲ್ಲ, ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅದಕ್ಕೆ ಸ್ಟ್ರೈಕ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ನೋಡೋಣ ಏನಾಗುತ್ತೆ ಅಂತ. ಲೈಕ್ ದಿಸ್ ವಿ ಹ್ಯಾವ್ ಲೈಟ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸು
10-15 ಇದೆ. ಓಕೆ, ಅದರಲ್ಲಿ 2 ತೋರಿಸ್ತಾ ಇದೀವಿ ಅಷ್ಟೇ. ಓಕೆ, ಶಾಲ್ ವಿ ಸ್ಟಾರ್ಟ್? ಓಕೆ, ಸಿ ನೌ. ಸ್ವಲ್ಪ ಹಿಂದೆ ಇಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಸಿ ದ ಡಿಫ್ರಾಕ್ಷನ್ ಸ್ಪಾಟ್ಸ್ ಹಿಯರ್. ಇಲ್ಲಿ ಸೀಲಿಂಗ್ ಮೇಲೆ ಕಾಣಿಸ್ತಾ ಇದೆ ನಿಮಗೆ. ನೀವು ಅಲ್ಲೇ ನಿಂತ್ಕೊಂಡು ನೋಡಿ. ನಿಮಗೆ ಕಾಣಿಸ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಬಿಟ್ಬಿಡಿ. ಓಕೆ ಓಕೆ, ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇರ್ಬೇಕು ನೋಡಿ ನಿಮಗೆ ಸ್ಪಾಟ್ಸ್ ಸೀಲಿಂಗ್ ಅಲ್ಲಿ. ಅವರು ಫೋಕಸ್ ಮಾಡಿದ್ದಾರೆ ಅಲ್ಲಿ ಟಿವಿಲಿ ನೋಡಿ, ಅಲ್ಲಿ ಪ್ರಾಜೆಕ್ಟರ್ ಅಲ್ಲಿ. ಓಕೆ, ಯು ಸಿ ದ ಪಾರ್ಟ್. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
Thank you, sir. Over to you, sir. Thank you.
ಥ್ಯಾಂಕ್ ಯು. ಮೈಕ್ ಇದೆಯಾ? ಓಕೆ ಓಕೆ, ಅದು ಹೋಯ್ತದು. ಓಕೆ, ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಆಫ್ಟರ್ ಲಂಚ್ ಎಲ್ಲರೂ ನಿದ್ರೆ ಮಾಡೋಕ್ಕೆ ಟೈಮಿಗೆ ಬಂದಿದ್ದೀರಾ ಇಲ್ಲಿ. ನಾನು ಮಾತಾಡೋದು ಆ್ಯಕ್ಚುಲಿ ಹೋಯ್ತಾ? ಓಕೆ, ವಾಟ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟಾಕ್ ಅಬೌಟ್ ಈಸ್ ಸಮಥಿಂಗ್ ದಟ್ ಎವ್ರಿಬಡಿ ವುಡ್ ಹ್ಯಾವ್ ಸೀನ್. ಆ ಫೋಟೋ ಎಲ್ಲರೂ ನೋಡಿರ್ತೀರಾ. ದಟ್ ವಿ ಆಲ್ ಇವಾಲ್ವ್ಡ್ ಫ್ರಮ್ ಮಂಕಿ, ಅವರ್ ಎವಲ್ಯೂಷನ್ ಹ್ಯಾಪೆಂಡ್ ಫ್ರಮ್ ಸಮಥಿಂಗ್ ಲೈಕ್ ದ್ಯಾಟ್ ಅನಿಮಲ್ ಅಂತ. ಬಟ್ ನಾನು ಏನು ಮಾತಾಡ್ತೀನಿ ಅಂದರೆ, ಹೌ ಡಿಡ್ ದಿಸ್ ಹ್ಯಾಪನ್ ಆ್ಯಕ್ಚುಲಿ? ಡಿಡ್ ಇಟ್ ರಿಯಲಿ ಹ್ಯಾಪನ್ ಲೈಕ್ ದಿಸ್? ಇಫ್ ಇಟ್ ಹ್ಯಾಪನ್ ಲೈಕ್ ದಿಸ್, what are all those animals? What are each of these animals? And are they alive today? Okay, that is what I am going to essentially talk about. Now, before I go there, I want to talk about one important rule in biology. Okay, and there are laws in physics, there are principles in chemistry, but there's really only one rule in biology, and this rule supersedes all other rules. Andre, this rule is the godfather of all rules in biology. Okay, and that rule is evolution by natural selection. Okay, you take any animal from the smallest virus to the largest blue whale, they will follow that rule. Okay, let me give you an example. Everybody was there during covid time alli ellaru idralva. ಎಷ್ಟು ಜನ covid bantu? Show of hands. How many people had covid? So less people are. ಬೇರೆ ಯಾರಿಗೂ ಬಂದಿಲ್ಲ. ಓಕೆ, ಯಾರಿಗೆ ಬಂತು ಅವ್ರಿಗೆ ವಾಟ್ ವಾಸ್? ಓ okay, so what is the one common symptom that you will have in COVID or any other respiratory disease? Lungs infection bandre one common symptom ಏನು? Sneeze. Yes, very good. One more, come on. Cough. Okay, why is it common? Because a virus ಬಂದ್ಬಿಟ್ಟು one patient ಇಂದ ಇನ್ನೊಂದು patient ಹೋಗಬೇಕು ಅಂದ್ರೆ it has to be thrown out. Okay, that is the evolution that the virus has adapted, because virus has to infect a new person. Like that, every single organism follows that rule, including us, including human being. So if we are saying that that means what is evolution by natural selection? Andre survival of the fittest, alva? So what is this fitness? What is so special about human beings? Okay, that's a good answer. Intelligence. Okay, let's see that is it true or not anta. Nan ಏನು ಮಾಡಿದ್ದೀನಿ ಅಂದರೆ, this is basically a graph of weight of the animal. A hedgehog is there, all of these animals are there. Okay, and you can see that more or less it is a straight line. That means if the body weight increases, brain will also increase proportionately. I mean, elephant's brain will be big, mouse's brain will be small. Correct? Can you see that line there in the middle? If not, I will draw one for you. Okay, this line is the line that defines intelligence in some sense. Okay, if you see whatever is above this line, okay, that means the brain is larger than the size of the body that is expected. And if you see the animal that is furthermost from that line will be human being. I have circled it there. Yeah, we are smart. Yes, we are intelligent and all that. There is no doubt about it. But ನಾನು ಕೇಳ್ತಾ ಇರೋದು, this time ಈ phase ಅಲ್ಲಿ okay, intelligence is important. Yeah, it really helped us survive and all of this. But what about here? How did we survive in that phase? What was special about us in that period of time when we were not a human being, when we were actually more of a monkey? Okay, let's just take an example of other animals. Okay, if you see other animals, what do they have for survival? Some of them are fast, they have speed, like you have cheetahs that can run at 120 kilometers per hour. You have, in birds, you have falcons that can fly at 200 kilometers per hour. Okay, you have strength. Animals like gorillas, they are our relatives. Gorillas, not Atra relative, but distant relatives. Okay, they have strength. They have other animals like lions, tigers, elephants. These are extremely strong animals. There are biological modifications which other animals have. They have sharp teeth, they have these long nails, they have this chameleon, they will camouflage. Ilandre, they'll have this thick skin like tortoise, turtles, those, or your snakes will have venom and all that. Some of them have endurance, like these wild dogs, they can run for hours together. Okay, that is called endurance hunting. They can do that. Acute senses, a dog's hearing, owl's eyesight, eagle's eyesight, all of this specialized senses. Rate of birth, like rabbits, in 1 year, two rabbits can become 400 rabbits at the end of 1 year. Okay, so the advantage is they will multiply faster. Okay, and lastly, animals like tortoises, sharks, and elephants. These animals naturally live very long. Okay, 100 years, 200 years. I think the oldest tortoise is something like 258 years or something. It's still alive somewhere. Okay, now let us see if we have any of those. Speed, are we fast? Compare with these animals. Okay, are we fast? We can run at the most 10 kilometers per hour. Adu uta admele we cannot run at all. Okay, speed is gone. Strength, are we as strong as gorilla or any of these other animals? Okay, then do we have long teeth, or claws, or camouflage, thick skin? Not what your teachers scold you. Actual, like turtles, thick skin, or venom? We don't. Endurance, can we run for 2-3 hours straight? We can't. What about senses? Do we have a dog's hearing or specialized eyesight? We don't have that. Our rate of birth is not great. We give birth to one child in every 9 months, right? So that's not great either. Long life, again, with science and technology, yes, you can live for 80 years, 90 years. But in the wild, if you are living in the jungle, you won't live that long. You live 30 years, maximum 40 years, that's it. Some infection will come and kill you. Okay? So then, idral yaudu illa nammatra. Then how did we really survive, this entire thing? How did we become? So this animal, okay, everybody knows the scientific name for humans, right? What is it? Homo sapiens, right? Good. So adralli the homo part is our genus name, it's our family name, and the sapiens is the species name. We are the only ones in our species that are there today. Okay? Now we evolved 25 million years ago. We evolved from this monkey. Okay? It's called Proconsul africanus. You can forget the name. Okay, we evolved from this, and when did it happen, Andre? If you see, if this is the timeline of the full universe from Big Bang till today, 13.8 billion years, you have all these important events. Apes evolved at the very, very end. We are very, very new species on this planet. We just came something like 3-4 million years ago, essentially. And just to show you, okay, some of you were there yesterday, I think, how big a billion really is. It's not a small number. Anybody know how many zeros a billion has? 9 zeros, okay? But just to show you how big it is, when I say billion, what is the first thing that comes to your mind? Elon Musk, right? Everybody knows him as a billionaire. You know how big $1 billion is? That's the number, okay? 1 followed by 9 zeros, 10 to the power of 9. Now imagine, okay, that's Elon Musk. If I give you 1 lakh rupees a day, okay, every day, 7 days a week, 365 days a year, you work like this for 2,000 years. Okay? By the way, 1 lakh rupees a day is more than all of the faculty's salary combined. Okay? It's more than that. We don't earn, all of us, if you add also, we won't earn. 1 lakh a day, 365 days a year, for 2,000 years, you will have $1 billion. That's how big that number is. And Elon Musk has 343 billion. Okay? You have to work at least for close to 7 lakh years to have as much money as that man. But that number is huge. We are the only ones in our species that are there today. Okay? Now, we evolved 25 million years ago. We evolved from this monkey. Okay? It's called Proconsul africanus. You can forget the name. Okay? We evolved from this. And when did it happen, Andre? If you see, if this is the timeline of the full universe from Big Bang till today, 13.8 billion years, just came something like 3-4 million years ago, essentially. And just to show you, okay, some of you were there yesterday, I think, how big a billion really is. It's not a small number. Anybody know how many zeros a billion has? 9 zeros, okay? But just to show you how big it is, when I say billion, what is the first thing that comes to your mind? Elon Musk, right? Everybody knows him as a billionaire. You know how big $1 billion is? That's the number, okay? 1 followed by 9 zeros, 10 to the power of 9. Now imagine, okay, that's Elon Musk. If I give you 1 lakh rupees a day, okay, every day, 7 days a week, 365 days a year, you work like this for 2,000 years, okay? By the way, 1 lakh rupees a day is more than all of the faculty's salary combined, okay? It's more than that. We don't earn, all of us, if you add also, we won't earn. 1 lakh a day, 365 days a year, for 2,000 years, you will have $1 billion. That's how big that number is. And Elon Musk has 343 billion. Okay, you have to work at least for close to 7 lakh years to have as much money as that man. But that number is huge. Okay, it's a huge number.
I now request Ms. Pooja Hegde to please come forward and offer a flower to Dr. Divya Patani as a token of respect.
Thank you so much.
Thank you, madam. Stage is all yours. Thank you.
Hello everyone. Awake or sleeping? I can't hear you. Awake? That's the way. You girls, women. See, we all have feminine and masculine part in all of us. Not just women, it's there in men also. So I'll say happy Women's Day to all men here who took part and also all women here who took part in this scientific outreach program. Okay, I consider that the great women here is Mother Universe, whom we don't know much about. I believe in her. There is always a her in everyone that I already told, but that her is a big one, the powerful force which we don't know about like much of it. So happy Women's Day to all, and with that, my topic was women in science, but I am not talking on this. Giving to a little glimpse of that, I had to talk on their security, what kind of societal pressures, family pressures, physical pressures they have, all the challenges they have to go on with. It's not just women who are going through all this. There are men. Just that they are silently fighting with these things. We women are considered, because we are weak, I consider it okay, fine. We are weak in physical way, but our brain are as similar as men. So we will utilize that brain in science of women we all have within us to progress, to show our country and the world and Mother Universe what we are. This is the point I just want to highlight. Not just women in science, we have to start with women in school. It's about their security, how they manage to talk with boys. I don't know how many girls here talk to boys. Some hesitation or something, I don't know. It's not always relationship term, doesn't come with love at first sight and all. It comes with studies also. I can tell you, I am here, I did my PhD because of my friends who are male. They motivated me to come in this field of science. So I thank them. I very much appreciate them. They bring me here. It was my power inside me, but they helped me. So don't hesitate to talk about science with your male friends also. They'll not eat you up. They are not carnivorous. So other than that, schools also have to consider some kind of safeties. Like physical safety should be there, mental safety should be there. Those things, okay, I'm not talking about that. I have just 15 minutes to talk. Let's come about my topic, which is curiosity. So, are you curious? Are we curious about things? In actual? No, we are not. Even scientists are not curious. I can say Shiv Prasad sir is curious. Other professors are also very curious. But the modern generation scientists, mostly women, are not curious. Even men also, they are just into something, their phones and all. But let's look into what curiosity is. So, ever been curious about when we work, when we eat, when we sleep? So, let's do an experiment. What happens inside our body when we feel something? Are we curious? Like, are we aware of what is happening? So, I'll tell you, let's stop this talk. Sleep. Literally sleep. Close your eyes. Let's do little meditation. Close your eyes. You're not listening to me. I'm telling you, close your eyes.
Everybody close your eyes.
It's an order. Okay, I don't have much time, otherwise I would have meant you to sleep for hours. Okay, open your eyes. You felt good? Ever thought of when you sleep or when you close your eyes, you are with yourself, how you feel, what is happening in your body? What is happening in your body? It's that relaxing is the one term, or it's that body is healing itself. It's that power, we are star seeds, we come from stars. That power is within us, that is highly activated when we sleep. That's why we feel good. Same thing goes with when we eat. Say I am very hungry, you all had food now, but I would offer you, if you are very fond of sweets, Atul, if you are very fond of sweets, I'll offer you this candy sort of chicky. You can give to some people. It's little, random. Anyone. Everyone wants now because it's sweets. It's okay. You give to anyone. Like, one piece. Already there. See the hand.
Then there is not a volunteer.
Okay, so maybe there are 10 or 12 pieces in that. So 10 or 12 people only will be getting it. How are you feeling? You are not getting it. Feeling bad? So there is something happening in your body. Those of the students who are going to go in biology, maybe they will be reading about it. That is where the curiosity lies. Curiosity about knowing things. It should be there. Your mama is cooking food, you are eating it, just you are eating it. What is happening while cooking? Low flame, high flame, added salt, sugar. What happens in that? So if you are curious about that, you will come to know the answers maybe by yourself, or you can ask some scientific students or teachers. You have opportunities always. So why? Why you are hesitant to take? I have not added poison in it. If you don't wish to take, I'll eat. How to be curious and why is it necessary being curious? You can question how the things works, why the things work, where to find these how and whys, and whom to ask. You can ask yourself first. Maybe you get the answer because you all have technology now. You can search on Google or some other platform or other available sources, like you have professors, teachers with you. You can ask them. Apart from that, asking and learning about it will evolve you. What you like, you will get the answer, you can progress. So there is a little scientist in all of us. Very little scientist in all of us. We all can become scientists. It's just that how curious we are to become that. Just that, a matter of fact. You consider that I am a scientist, you yourself. Consider that I am a scientist, you are a scientist. Your body is already working in that way. So, is really science is everywhere? Yeah, there is always something behind everything that you have to search for. So, you have to be aware. It's a topic of vast adversity and never-ending predictions, reality, perseverance, and existence. So, I already discussed about this. The food we eat, you have seen today's attended all the other lectures. So, these parts are already explained. The food we eat, the water we drink, or the air we breathe in. What are these made up of? How the particles move, you have already seen a demonstration by Vinayak sir and Raja sir. So you know all these answers, but still these are very simple questions. Other questions come into your mind. You should be aware of where you are standing, what question is coming into your mind, and where to get the answers. Next part, very simple thing is curiosity about cooking. So what is the role of you get a cake and all? You see a cake, you eat a cake, it's very spongy. How it becomes very spongy? Answer is baking soda. Baking soda we use, that's why it becomes spongy. Someone will answer like that. What is the reason behind that? Is there science in that? What is the science? What is that? Someone is telling something. Hey, it's okay. Tell, stand and tell.
Those who answer, we have goodies. It is second time.
Tell, we'll get you that chicky.
No, we give pencil.
Oh, okay. What is there in baking soda? What is coming out of baking soda on heating? Why the cake is becoming fluffy? Why it is sponge type? Anyone? Raise your hand. Listen. Yes, carbon dioxide is there. So when carbon dioxide is forming, with heating carbon dioxide is forming and solid particle is already there, that carbon dioxide is trapped. After trapping, the solid materials have holes in it, it becomes like a sponge. So that is a cake, which is because of carbon dioxide evolution from NaOCl, our baking soda. Okay, other part is good digestion, fermented food. So I'll tell you that fermented food is like you keep it outside, ferment it, there are good bacteria in it, you eat it. After eating, that is highly digestible other than like with respect to the food which we take directly. Those who are listening to me, the question why fermented food is good for health, you can mail me the answer. But how will I give the goodie then? Or if you know, you can tell me now. Why fermented food is good? Bacteria. Then, what is that bacteria? What is it doing? Okay, at least you have been curious. You read about it and you can send me a mail with the answer. I will say give you a big good smiley as a goodie. Okay, so it's an involvement of bacteria only. Bacteria is already digesting the food outside our stomach. Then we are taking it in. So already the material has become very small size, which our stomach usually do. That's why it gets digested very quickly. So that's the answer. And apart from that, if you know, you can mail me. Okay, so curiosity about medicines. So how the medicines work. These all things are just like how things work. So he tried so many experiments to get that bulb in function, but every time he was failing. So when he failed and finally succeeded after thousands of times, he just say one thing. I have not failed those 999 times. I have got experience in those 999 times to get that 1% success. And that 1% success we are using daily in our home here also. Bulb, hai? So that mindset should be there. That persistence should be there. You are failing, and you are learning from it. No, you are not breaking, you are not quitting at that point. So 1% inspiration and 99% perspiration can make you a very great scientist and like sir say, Nobel laureate also. Maybe. So he is also my favorite, Sir Stephen Hawking. He talks about space-time relations, exploration of universe and power of human spirits. So he was at age 21 when he got diagnosed with neurodegenerative disorder. So doctor told him he will die in 1 or 2 years, but he lived till 76 of his age. His brain was still working. He designed various theories, various things about. He was very great theoretician. So he say that thinking creatively and out of the box can lead to great successes. So just that Everything is same. Just that where we are going, where our thinking is going. Whether we are aware of what is happening and we are thinking in the perfect direction. So that's the way of dealing with daily life, with your professional life, with your personal life, and going with the flow. So Sir Albert Einstein he is the one who says curiosity above all, which is the title of my talk today. So I have no special talent. He used to say that. He used to sit as a backbencher in his school time. He says, I have no special talent. I am only passionately curious. I'm just curious. If this ant is climbing, falling, then climbing again, I'm curious why she is doing that. Just curious. That curiosity will lead to answers from oneself. You will get the answers. If you are very definitely determined about getting the answer, you will get the answers. Major global warming issue with the fuels which we use, non-biodegradable, like coal, petroleum and all. We have to shift from those coal, petroleum to a green substitute, which is hydrogen. So we use electrocatalysis in our lab to produce hydrogen and oxygen, and we try to fabricate large size electrodes so that we can get high quantity of hydrogen fuel, which can be used, as you know, in various places. Electric vehicles are available, hydrogen fuel vehicles are available. Major issue with hydrogen is the storage. So we want grid formation of hydrogen. So that way we work with. Final thing is advice. Whatever you do or study, don't be just in your books. First thing, you have to be entertaining yourself always, even if you are studying. You have to be happy. You have to be peaceful. If you are not feeling like studying, okay, fine, close your eyes for 5 minutes. Let it go, let that feeling go, sadness, then start again. Look around in space. Mother Earth is such a beauty. To explore mysteries, curiosity in you, above all, with what you do and think of, you can actually find and discover the science behind it. It's always there. We just have to look for it. So that perspective should be there. I want to look for it. If you don't want, you will not see it, even if it's standing in front of you. So either you get lost and live, you go out somewhere, you are fed up with your life, you go out, live somewhere very calmly, no one is there, you are just alone, or you live and get lost in your imagination. Finally, and health is a very important factor over everything. You have 1,000 billion rupees, what Arun was telling, it's a huge amount, but you don't have a good health. We'll be seeing you in the with the doctor only, Better than that, you take care of your health first. Health is the primary thing, the first priority everywhere. If you are healthy, you are alive, then only you can work, you can deal with life. Otherwise, if you are not there, who will be seeing you? You will be in some other dimension after you're dead. So, take care of your health.
ನಿನ್ನೆ ಬೆಳಿಗ್ಗೆಯಿಂದ ಇವತ್ತಿನವರೆಗೆ ಸುಮಾರು 11 ಜನ ವಿಜ್ಞಾನಿಗಳು ನಿಮ್ಮ ಹತ್ರ ಮಾತಾಡಿದ್ದಾರೆ. ಈ 11 ಜನ ವಿಜ್ಞಾನಿಗಳಲ್ಲಿ ಎಲ್ಲ ವಿಚಾರಗಳ ಬಗ್ಗೆ ನಿಮ್ಮ ಹತ್ರ ಮಾತಾಡಿದ್ದಾರೆ. ಎಷ್ಟೆಷ್ಟು ವಿಚಾರಗಳ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ದಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ನೋಡಿ, ಮೊದಲಿನದಾಗಿ ದಿವ್ಯಾ ಅವರು ಈಗ ಕೊನೆಯ ಟಾಪ್ ಕೊಟ್ಟರು, ಡಾಕ್ಟರ್ ದಿವ್ಯಾ ಬುತಾನಿಯವರು. ಅವರು ರಿಸರ್ಚಲ್ಲಿ ರಿಸರ್ಚು ಮತ್ತು ಲೈಫ್ನಲ್ಲಿ ಕ್ಯೂರಿಯಾಸಿಟಿಯ ಪಾತ್ರ ಏನು ಅಂತಕ್ಕಂಥ ವಿಚಾರದ ಬಗ್ಗೆ ಮಾತಾಡಿದ್ರು. ಅಂದರೆ ಪ್ರತಿಯೊಬ್ಬ ಮನುಷ್ಯನಿಗೂ ಕ್ಯೂರಿಯಾಸಿಟಿ ಇರಬೇಕು ಅಂತಕ್ಕಂಥ ವಿಚಾರನ ಹೇಳಿದರು. ಪ್ರೊಫೆಸರ್ ವಿದ್ಯಾಧಿರಾಜ ಅವರು ಥಿಯರಿಟಿಕಲ್ ಸೈನ್ಸ್ನಲ್ಲಿ ತುಂಬ ಒಳ್ಳೆಯ ವಿಜ್ಞಾನಿ. ಆದರೆ ಇವತ್ತು ನಿಮಗೆ ಫಿಸಿಕ್ಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟನ್ನ ತುಂಬ ಮನೋಜ್ಞವಾಗಿ ನಿಮಗೆ ತಿಳಿಸ್ಕೊಟ್ರು. ಡಾಕ್ಟರ್ ಅರುಣ್ ಅವರು ಎವಲ್ಯೂಷನ್ ಬಗ್ಗೆ, ಯಾಕೆ ಎವಲ್ಯೂಷನ್ ಆಯಿತು ಅಂತಕ್ಕಂಥ ಒಂದು ಹೊಸ ವಿಚಾರನ ತಿಳಿಸ್ಕೊಟ್ರು. ಪ್ರೊಫೆಸರ್ KR ಶ್ರೀನಿವಾಸ್ ಅವರು ಎಂಜಿನಿಯರಿಂಗ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಯೂನಿಟ್ ನಲ್ಲಿ ಜವಾಹರ್ಲಾಲ್ ಯೂನಿವರ್ಸಿಟಿಯಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಾರೆ. ಅವರು ಸಹ ನಿಮಗೆ ಹೊಸ ಒಂದು ವೈಜ್ಞಾನಿಕ ವಿಚಾರವನ್ನ ತಿಳಿಸ್ಕೊಟ್ರು. ಅದರಲ್ಲಿ ಅವರು ಯಾಕೆ ಫ್ಲೈಟ್ಗಳು ಹೋಗ್ತವೆ, ಹಕ್ಕಿಗಳ ಮಾಡೆಲಿಂದ ನಾವು ಯಾಕೆ ಏರೋಪ್ಲೇನ್ಗಳನ್ನ ಹಾರಿಸಲಿಕ್ಕೆ ನಾವು ಈ ರೀತಿಯ ಮಾಡೆಲ್ಗಳನ್ನ ಕಲಿತು ಅದರಲ್ಲಿ ಯಾವ ರೀತಿಯ ವಿಜ್ಞಾನ ಇದೆ ಅಂತಕ್ಕಂಥ ವಿಚಾರವನ್ನ ತಿಳಿಸಿದ್ರು. ಪ್ರೊಫೆಸರ್ ಈಶ್ವರ್ ಮೂರ್ತಿ ಅವರು ನ್ಯಾನೋ ಮೆಟೀರಿಯಲ್ಸ್ ಮತ್ತು ಕೆಮಿಸ್ಟ್ರಿ ಬಗ್ಗೆ ನಮಗೆ ತುಂಬಾ ಚೆನ್ನಾಗಿ ತಿಳಿಸ್ಕೊಟ್ರು. ಸುಬಿ ಜಾರ್ಜ್ ಅವರು ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಸೂಪ್ರಾಮಾಲಿಕ್ಯುಲರ್ ಕೆಮಿಸ್ಟ್ರಿ ಇದೆ ಅಂತಕ್ಕಂಥ ಒಂದು ಹೊಸ ವಿಚಾರ, ಅದು ನಮಗೂ ಗೊತ್ತಿರಲಿಲ್ಲ. ಅದ್ರ ಬಗ್ಗೆ ಅವರು ರಿಸರ್ಚ್ ಮಾಡಿದ್ರು. ಪ್ರೊಫೆಸರ್ ಶಿವಪ್ರಸಾದ್ ಅವರು ಲೈಫ್ ಬಗ್ಗೆ, ರಿಸರ್ಚ್ ಬಗ್ಗೆ ಮತ್ತು ನಾವು ಏನ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನ ತುಂಬಾ ತುಂಬಾ ಮನೋಜ್ಞವಾಗಿ ನಿಮ್ಮ ಮನಸ್ಸಿಗೆ ತಟ್ಟುವಾಗಿ ಹೇಳಿದ್ರು. ನಿನ್ನೆ ನಮ್ಮ ಡಾಕ್ಟರ್ ಶ್ವೇತಾ ಶಿವಪ್ರಸಾದ್ ಅವರು ಮೊದಲನೇ ಟಾಕ್ ಶುರು ಮಾಡಿದ್ರು. ಇದು ಅಂತಾರಾಷ್ಟ್ರೀಯ ಮಹಿಳಾ ದಿನಾಚರಣೆ ಅಂಗವಾಗಿ ಅವರೇ ಈ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮಾಡಿ ಬಯಾಲಜಿನಲ್ಲಿ ಹೊಸ ವಿಚಾರಗಳನ್ನ ನಮಗೆ ತಿಳಿಸ್ಕೊಟ್ರು. ಅದರ ಪಕ್ಕದಲ್ಲಿ ವಿನಾಯಕ್ ಬತ್ತರ್ ಇದ್ದಾರೆ. ವಿನಾಯಕ್ ಬತ್ತರ್ ಬಂದ್ಬಿಟ್ರೆ ಅವರೊಂಥರ ಸಚಿನ್ ತೆಂಡೂಲ್ಕರ್ ಇದ್ದಂಗೆ ಬ್ಯಾಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವರು. ಹಾಗಾಗಿ ಎರಡು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನಲ್ಲಿ ಅವರು ಭಾಗವಹಿಸಿದ್ರು. ಜೊತೆಗೆ ತಮ್ಮದೇ ಆದಂತ ಶೈಲಿನಲ್ಲಿ ನಿಮಗೆ ವಿಜ್ಞಾನದ ಬಗ್ಗೆ ಕೌತುಕಗಳನ್ನ ಅವರು ಇದು ಮಾಡೋದಕ್ಕೆ ತಲುಪಿಸೋದಕ್ಕೆ ಪ್ರಯತ್ನ ಪಟ್ಟರು. ಡಾಕ್ಟರ್ ಪ್ರತಾಪ್ ವಿಷ್ಣೋಯ್ ಅವರು ಈಗ ಬರ್ತಾ ಇದ್ದಾರೆ. ಪ್ರತಾಪ್ ವಿಷ್ಣೋಯ್ ಅವರು ನಿಮಗೆ ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಒಳ್ಳೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನ ಕೊಟ್ಟರು. ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ತಾ ಇರ್ತಕ್ಕಂಥದ್ದು ಇಷ್ಟೇ, ಜವಾಹರ್ಲಾಲ್ ನೆಹರು ವಿಜ್ಞಾನ ಸಂಸ್ಥೆ ಒಂದು ಹೈಯರ್ ಇದರಲ್ಲಿ ಸೈನ್ಸ್ ಅಂಡ್ ರಿಸರ್ಚ್ ನಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಕ್ಕಂಥ ಸಂಸ್ಥೆ. ಇವರೆಲ್ಲರೂ ಸಹ ಅವರ ಲ್ಯಾಬೋರೇಟರಿಗಳಲ್ಲಿ ಇರ್ತಾರೆ, ಹೆಚ್ಚು ಕಮ್ಮಿ ಅವರ ಲ್ಯಾಬೋರೇಟರಿಗಳಲ್ಲಿ ಇರ್ತಾರೆ. ಅವರು PhD ಸ್ಟೂಡೆಂಟ್ಸ್ ಜೊತೆ ವರ್ಕ್ ಮಾಡ್ತಾರೆ. 2 ದಿವಸ ಅವರ ಸಮಯವನ್ನ ತೆಗೆದುಕೊಂಡು, ಅಂದ್ರೆ 2 ಆಗಲ್ಲ 3 ದಿವಸ ಆಗುತ್ತೆ, 3 ದಿವಸ ಅವರ ಸಮಯನ ತೆಗೆದುಕೊಂಡು ನಿಮ್ಮ ಜೊತೆ ಕಳೆಯೋದಕ್ಕೆ ಬಂದಿರ್ತಕ್ಕಂಥದಕ್ಕಾಗಿ ನಾನು ಜವಾಹರ್ಲಾಲ್ ನೆಹರು ಸೆಂಟರ್ ಸಂಸ್ಥೆಯಿಂದ ಅವರೆಲ್ಲರಿಗೂ ನಾನು ಆಭಾರಿ ಮತ್ತು ಧನ್ಯವಾದಗಳು. ಈ ಪ್ಯಾನಲ್ ಡಿಸ್ಕಷನ್ ಅಲ್ಲಿ ಅವರು ಎಲ್ಲರೂ 2 ನಿಮಿಷ ಮಾತಾಡ್ತಾರೆ. ಅವ್ರು ಆದ್ಮೇಲೆ ನಿಮ್ಮ ಪ್ರಶ್ನೆಗಳನ್ನ ದಯವಿಟ್ಟು ರೆಡಿ ಮಾಡ್ಕೊಳ್ಳಿ. ನೀವು ಯಾವ ಪ್ರಶ್ನೆ ಕೇಳಿದ್ರು ನಮಗೆ ಬೇಜಾರಾಗೋದಿಲ್ಲ. ಎಲ್ಲ ಪ್ರಶ್ನೆಗಳಿಗೂ ಸಹ ಸಾವಧಾನವಾಗಿ ಉತ್ತರ ಕೊಡ್ತೀವಿ. ನೀವು ಪ್ರಶ್ನೆ ಕೇಳೋದನ್ನ
ನೀವೆಲ್ಲರೂ ಇನ್ಸ್ಪೈರ್ ಆಗಿ ಇವತ್ತು ಇಲ್ಲಿ ಬಂದಿದ್ದೀರಾ. ಸೊ ಕೀಪ್ ಗೋಯಿಂಗ್. ಐ ವಿಶ್ ಯು ಆಲ್ ದ ಬೆಸ್ಟ್. There is one thing I want to say, that Women's Day is not just a celebration of women, but it's also celebration of the men in your life who have always supported you. So first ನಿಮ್ಮ ಮನೆಯಲ್ಲೇ ಆಗಿರ್ಬೋದು, ನಿಮ್ಮ ಅಪ್ಪ ಅಥವಾ ನಿಮ್ಮ ತಾತ ನಿಮ್ಮನ್ನೆಲ್ಲ ಸ್ಕೂಲಿಗೆ ಹೋಗಿ ಕಳ್ಸಕ್ಕೆ ಎನ್ಕರೇಜ್ ಮಾಡಿರ್ಬೋದು, ಅಥವಾ ಇಟ್ ಮೈಟ್ ಬಿ ನೀವು ತುಂಬಾ ಚಿಕ್ಕವರು, ಬಟ್ ಆಸ್ ಯು ಗ್ರೋ ಅಪ್ ಮೇಬಿ ವಿಲ್ ಬಿ ಸರೌಂಡೆಡ್ ವಿತ್ ಫ್ಯಾಮಿಲಿ, ಅತ್ತೇನೋ ಅನ್ನೋರು, ಹಸ್ಬೆಂಡ್ ಆ ಥರ, and they might be the ones who are supporting you. If ನಾನು ಇಲ್ಲಿಗೆ ಬರಬೇಕು ಅಂದ್ರೆ ಯಾರು ನನ್ನ ಮಕ್ಕಳನ್ನ ನೋಡ್ಕೋಬೇಕಲ್ಲ. So it's also the celebration of all the men around you who are supportive of you in doing your
way. I have not much to say, but yes, there are few things which I have seen, that we are all silent. You should be always ready to speak up. Whatever is there in your mind, you should be at least ready to say, yes, I have a question, I have a query. That should be there in everyone, because our future generation need those kind of people who point out things and who say that I have a query, I want to know something. It's not just everyone is dealing with so many things, but apart from that, whatever you are doing, be focused in that and go with the flow with your life also. But in your studies, at least try to come up as a person or as a being who is actually proud of yourself. Like, you should be proud of yourself that okay, I am in this position. There are so many people out there who can't even come to schools. They're not allowed. Especially girls are not allowed to come to schools. But you have that opportunity. Take care of it. If we are asking, you have a question, you should ask us. I have a question. You should be the first to ask. So don't get afraid of what I will say. Even if your question is stupid, even if my answer is stupid to you, you will be knowing how much I know, how much you know. After asking the question, you will surely going home and reading about it. So that part I want to say, not just to the boys also. You are not asking question. That's what I have seen as a limitation of the today's schools and colleges. They are not asking questions. They are not asking the queries. So So you should be ready for that. You should feel happy in asking questions. It's a very powerful thing. It's not easy, but you have that power in you. You should ask questions. That's it. Thank you so much for letting me here, being a part of this science outreach program.
Success favors prepared mind, which is somebody. So you have to be open to the new ideas, open to work hard, study more, and of course you have to see what is happening around you and then learn and interpret things. Many times, whatever that we are here to talk to you, it's not that you have to go over here, this area, that area. You can be a scientist or you can be an engineer, whatever things you do, it's only a curiosity drives everyone. So working hard and the curiosity, if you blend these two, you will be in a different level. So that's very important. And many times, many scientists' discoveries comes with the scientific. In catalysis, we used to say that somebody was doing the reaction, he was not having the stirrer to mix the solution and use whatever thermometer he was carrying, just use that one. Suddenly got the thermometer broke and the reaction catalyst to it, whatever the mercury was there in the thermometer. So therefore, that's an important catalyst. Yeah.
Thank you, Jayachandra. I did not follow completely what you told, but still. So, good afternoon. First of all, thanks. Very nice feeling to be here. So, we are here, as Professor Prasad mentioned, we are here not to convert all of you to scientists, but the purpose was to come and talk to you and probably to tell you that find excitement in learning science. So, so it has to be like, so it's not, the purpose is not to get full mark, but to get that excitement and to learn new things. So that is the kind of self-driven, that you should be motivated to do that. So that's why I think we are here, to tell you, find excitement in learning science. And second thing is, so when you study, so most of us, so it's a kind of advice, so to understand like conceptual thing behind it rather than by heart. So most of us, like this, we sit in interview boards, and sometimes we see that students with like 99.99, especially from students from Kerala, when you look into the mark list, it is like 99.999% mark. But when they come to interview, and then we ask questions, we don't ask directly questions, right? We ask questions in a kind of indirect way. Then we realize that most of them probably not in a position to answer them. So understand chemistry, and you have wonderful teachers here. That is one more advice. Already people talked about it. So that's something is understand and learn. Finally, the last thing I would like to say is ask questions. Already, again, my colleagues mentioned about it. So actually, I got one question, very nice question. Can we create artificial life or artificial cell out of this molecular chemistry? So you should be open to, that's a wonderful question. That should be the way people should think. So the supramolecular chemistry, I just yesterday gave some brief introduction. So this is a field originated from curiosity.
I am probably the only person here who also had a chance to talk to the 6th to 9th standard students in NA. And this is a point I think everybody has made, and I am making it again because I had one observation that 6th and 9th tanka, they did not leave me. They bombarded me with questions, both in in the classroom as well as on the field yesterday. Interestingly, I saw many people here who are asking me questions in the field yesterday, but here there is really not a lot of questions that were being asked. And the only answer that I can think of is this fear that comes in as to, oh, what if this is not a good question or something. Because only it is just two people who come ask me the same question. And somewhere between that, after 9th standard, between, I don't know, college, that fear comes in. And that I think is something that is a big deterrent, not just in science. You should never be afraid to ask questions, whether it is science or whether it is life. Something wrong is happening in front of you, ask questions. Radharam Mohan Roy questioned Sati, he questioned child marriage. Gandhi, every instance of progress for humanity is happened because somebody asked a question. Okay, so that's one thing that I want to say, don't be afraid. Irrespective of what the question is, it may be foolish. Some of the greatest scientists, greatest people in the world have asked foolish questions. I'm sure you've heard of Newton's famous, two-door thing. I don't know if it is true, but it's a very famous thing. Isaac Newton made 2 holes in his door, one small hole and a big hole, for 2 cats. Somebody asked him why one small cat and a big cat. Somebody asked why do you need 2 doors? He said the small hole is for small cat and big hole is for big cat. So then somebody said, but the small cat can come through the hole made for the big cat, and Newton never realized it. I don't know if this is true, but the important point is that even great men make mistakes. They ask foolish questions. Don't be afraid to ever ask questions. So that's the thing. All the best to everyone.
Okay, ತುಂಬಾ ಥ್ಯಾಂಕ್ಸ್ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಷನ್ಗೆ, SDMಗೆ ಆ್ಯಂಡ್ ಅವರ JNCASR ಅಡ್ಮಿನಿಸ್ಟ್ರೇಷನ್. ಆ್ಯಂಡ್ ಎಲ್ಲದಕ್ಕಿಂತ ದೊಡ್ಡದಾಗಿ ಅಂದರೆ ಒಂದು ಗ್ರೇಟ್ ನಮ್ಮದು ಥ್ಯಾಂಕ್ಸ್ ಯಾರಿಗೆ ಅಂತಂದರೆ ಜಯಚಂದ್ರ ಸರ್. ಯಾಕಂತಂದ್ರೆ ಈ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೋಗ್ರಾಮ್ ನಡಿಬೇಕಂದ್ರೆ ಬಿಕಾಸ್ ಆಫ್ ಜಯಚಂದ್ರ ಸರ್ ಆ್ಯಂಡ್ ಯುವರ್ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಷನ್. ಅವೆಲ್ಲ ಒಂಥರ ಅರ್ಜುನ ಇದ್ರೆ ಅವ್ರೊಂಥರ ಸಾರಥಿ ಇದ್ದಂಗೆ, ಕೃಷ್ಣ ನಮ್ಮನ್ನೆಲ್ಲ ನಡೆಸ್ಕೊಂಡು ಬರ್ಬೋದು. ಯಾ. And of course, Atul, he coordinated with this thing, and Atul also, the administration of this thing. And JNCASR sir, yeah, and his teacher, because they helped him to come over here. Yeah, chair, chair NCU, Professor Subi George. Okay, see, ನನಗೆ ಭಾಷಣ ಮಾಡಕ್ ಬರಲ್ಲ, ನನಗೆ ಏನು ಮನಸ್ಸಲ್ಲಿರುತ್ತೆ ಅದನ್ನ ಹೇಳ್ಬಿಡ್ತೇನೆ. ಒಂದು ವಿಚಾರ ಏನು ಅಂತಂದ್ರೆ ಇಷ್ಟೆಲ್ಲ ಇದನ್ನೆಲ್ಲ ಕಾರಣಕರ್ತರಿಗೆ my special thanks to the Jayachandra sir.
We are able to do what we do in our labs because we know there are people like Jayachandra sir, especially Jayachandra sir, who has been always been the man who stands behind the curtain. ಅಂದ್ರೆ ಯಾವಾಗಲೂ ಕ್ರೆಡಿಟ್ ತಗೊಳ್ಳಲ್ಲ, ನಾನು ಮಾಡಿದ್ದೀನಿ, ನನ್ನ ಇದು ಅಂತ. When he was the administrative officer, I remember my room was near his house only. 8 o'clock he will walk to his office, and when I am leaving my lab at 8:30 in the evening, he will be working in his office still. And he is a great source of inspiration and a man who is really, for all of us, we won't be able to do what we do if he was not there. And I think even in this program, he is the main guy who has made it happen and possible. Of course, Atul also to a large extent. Thank you.
Spiritualism, whether it's a science or thing, you need to say what is science you have to define. See, many of the things based on the definition, you said whether it's something is vegetarian or non-vegetarian. When we do not define that and try to seek an answer, most of the time, question should be fired very clearly. If you say yoga is a spiritual, let's say, there are benefits of yoga and it is science because it has been studied to an extent. There may be something which has been done wrongly, okay, without having basis, that is not science. Okay, hence you need to know what is done systematically, then there is a causation, there is a effect which has been documented. Those part of the practices, you can call it as science. If there is a basis for your argument or whatever you do. If you don't have an argument based on hard facts, then it will be a belief, it's a faith. Okay, the difference between a faith and the science is that science is based on experimentation, asking a question which can be negated by a set of experiment, which can be proved either this or that. If you don't have that, then it is not science. That's all I would like to say.
ವಿಚಾರದ ಬಗ್ಗೆ ನಿಮಗೆ ಎಕ್ಸ್ಪೋಜರ್ ಕೊಡಬೇಕು ಅಂತ ಹೇಳಿ ಬಹಳ ಪ್ರಯತ್ನ ಪಡ್ತಾ ಇದ್ದಾರೆ. ಈ ಲ್ಯಾಬೊರೇಟರಿ ಇದನ್ನೆಲ್ಲ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಯಾವ ರೀತಿ ಮುಂದುವರಿಬಹುದು, ಯಾವ ರೀತಿ ರಿಸರ್ಚ್ ಸೆಂಟರ್ ಇದೆ, ಕ್ಯೂರಿಯಾಸಿಟಿ ಡ್ರಿವನ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಸ್ ಅಥವಾ ಒಂದು ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಏನೇನು ವ್ಯವಸ್ಥೆಗಳು ಬೇಕೋ ನಿಮಗೆ ಇದೆ. ಅದನ್ನ ನೀವು ಹೆಚ್ಚು ಉಪಯೋಗ ತಗೊಂಡು ನೀವು ಯಾವ ರೀತಿ ಮುಂದುವರ್ತೀರಾ ಅನ್ನೋದು ನಿಮ್ಮ ಕೈಯಲ್ಲಿ. ಅದು ಒಂದನ್ನು ನಾನು ನಿಮಗೆ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. ಎರಡನೇದಾಗಿ ಈಗ ಇವ್ರು ಹೇಳ್ತಾ ಇದ್ರು ಇಂಜಿನಿಯರ್ ಆಗ್ಬೇಕಾ, ಡಾಕ್ಟರ್ ಆಗ್ಬೇಕಾ ಅಥವಾ ಇನ್ನೊಂದು ಆಗ್ಬೇಕಾ ಅನ್ನೋ ಒಂದು ಪ್ರಶ್ನೆ ನಿಮ್ಮ ಮನಸ್ಸಲ್ಲಿ ಯಾವಾಗಲೂ ಇದಾಗುತ್ತೆ. ಮೊದಲನೇದಾಗಿ ನೀವು ತಿಳ್ಕೊಬೇಕಾದ ಏನಂದ್ರೆ ನಿಮಗೆ ಯಾವುದರಲ್ಲಿ ಹೆಚ್ಚು ಆಸಕ್ತಿ ಇದೆ, ನಿಮ್ಮಲ್ಲಿ ಯಾವ್ದನ್ನ ಮಾಡ್ಲಿಕ್ಕೆ ನಿಮ್ಮಲ್ಲಿ ಶಕ್ತಿ ಇದೆ ಅನ್ನೋದು ನೀವು ತಿಳ್ಕೋಬೇಕು. ಯಾಕಂದ್ರೆ ಅದನ್ನು ಬೇರೆ ಹೇಳಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ.
Those are all ignorances. Ignorance can be interpreted in terms of faith, belief, spirituality, whatever you want. But reality is science. There is no doubt about that. But that science doesn't claim that it knows everything yet. So slowly we are trying to know more and more. The more we know, all these aspects are going further and further away. So we don't know when it happens. This is my strong.
George's question what he asked about regarding life.
So my question is to Arun sir, like about this session, what he said today. So he mentioned that chimpanzees have great strength and endurance, like speed skills. We humans have less skills of those like endurance and strength. So does it mean that as evolution goes on, evolution goes on, humans will have very less strength and very less like speed skills? And is there a possibility that humans will also come to extinct one day?
That's a very good question, and the answer is no. I don't think there is any animal on the planet that can make humanity go extinct except human beings themselves. If we go extinct, it will be because of our own actions. We have crossed that threshold where nature can actually have significant effects on us. I'm not talking about extremes like asteroid hits or something like that. But the cause of any animal causing extinction to humans is close to zero. Does that answer your question?
Thank you.
Thank you.
The moment you want to do something, that is the most auspicious day. So there is nothing about that auspicious day. In terms of any river was contaminated, we also saw that even the Kumbh Mela, the river was contaminated even before the bath were taken. Environment ministries gave a lot of information, etc. Now it is of course more contaminated, but it's a matter of faith. Okay, you can't question the matter of faith. But I'm not talking about faith. That's what I said. See, that's why I said no. Pure science. And that's what pure science. It is very bad. Whatever happened is very bad. Faith is different. Fiction is different. Art is different. That's why I said nothing. There is no faith. Nothing like that. Okay, I am just telling. I think scientifically everything was contaminated, and there is nothing called as auspicious. My personal.
Thank you.
I often heard that science is a boon as well as grant. That is, you have analyzed, in fact, most of the good things of the science and its research. In fact, it is necessary for the growth of any economy also. What extent this science can be best developed, and up to what extent it would be creating havoc to the building of the nation? What are the hazards of this science and technology? One fine morning it will occur, no? Day after tomorrow.
Yeah. You asked about science is a boon and also it could be a pain in terms of when we use it in the wrong way. Okay. Whether you ask about the pollution or I did see an advertisement about benefit of using plastic. In an old newspaper, actually Mayura or something, 1970s or something, the people propagating usage of plastic. Okay, but now we know what is the problem with the plastic. It doesn't degrade, decompose, and cause a problem to the nature. Or whether you talk about atomic energy, as the shooters was saying in the morning, it is a boon when you use it to control way and do it. But it's a bane when we use it as atomic or even the pollution what it can create when we don't know how to process it or how to get rid of it. Hence, there is always a balance. ಈಗ ಚಾಕು ಇದೆ ಅಂತ ಅಂದ ತಕ್ಷಣಕ್ಕೆ ಅದು ಆಯುಧನೂ ಹಾಕಬಹುದು, ನಿಮ್ಮ ಮನೆಯೊಳಗಡೆ ಕಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಅಡಿಗೆ ಮಾಡ್ಲಿಕ್ಕೆ ಒಂದು ಉಪಕರಣನೂ ಹಾಕಬಹುದು. ನಾವು ಅದನ್ನು ಯಾವ ತರ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಯಾವ ರೀತಿ ಮಾಡ್ತೀವಿ ಅಂತ. ಈಗ ಹೆಚ್ಚಾಗಿ ಈಗ ಆಯಿಲ್ ಇದ್ರ ಬಗ್ಗೆ ಬಹಳ ಇದಿದೆ. ನಾವು ಆಯಿಲ್ ಬರ್ನ್ ಮಾಡ್ತೀವಿ, ಗ್ರೀನ್ ಹೌಸ್ ಗ್ಯಾಸ್ ಮಾಡ್ತೀವಿ, ಬಟ್ ಅದಕ್ಕೆ ಪರಿಹಾರ ಏನು ಅನ್ನೋದನ್ನು ನಾವು ಯೋಚನೆ ಮಾಡ್ಬೇಕು ಅಲ್ವಾ? ಇಷ್ಟು ಜನ ಓಡಾಡಬೇಕು, ನಮ್ಮ ಲೈಫ್ ಈಸ್ ವೆರಿ ಹೈ ಸ್ಪೀಡ್.
I am in college, so fourth year in college currently, and I in ISR Mohali. So I haven't really seen this kind of exposure. The labs you guys have, it's actually incredible. And I went around, and I've been around with my dad. So Professor Vidyadhiraja is my father. So with him, I've been around to a few outreach programs. But again, this kind of exposure you have is actually very nice to see, and I really want you guys to use it. Because I didn't have it, and if I did, I would have loved to have it in school and college. I like the environment you guys have currently, and I would want you to use it to the fullest. Thank you.
Chemistry today, Professor C.N. Rao Bhattana, ಅವರಿಗೆ
ನ್ಯೂ ಫಾರ್ಮ್ಸ್ ಆಫ್ ಕಾರ್ಬನ್, ಇದು ಸಹ ಪ್ರಶಸ್ತಿಗಳನ್ನ ನಾವು
ಸೊ ಅವ್ರ ಮುಂದೆ ಅವ್ರ ಎದುರಿಗೆ ನಾನು ಮಾತಾಡುವಷ್ಟು ದೊಡ್ಡವನಲ್ಲ, ಬಟ್ ಆನ್ ಟು ದ ಬೆನಿಫಿಟ್ ಆಫ್ ಸ್ಟೂಡೆಂಟ್ಸ್. ಸಾರಿ, ನಂದು ಕನ್ನಡ ಮಾತಾಡ್ತಿದ್ದೆ, ಬಟ್ ಕನ್ನಡ ಇವಾಗ JNCASR ಇಟ್ಸ್ ಯಾವ ತರ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ ಅಂದ್ರೆ ವಿ ಹ್ಯಾವ್ ಪೀಪಲ್, ಅಂದ್ರೆ ಜನ ಎಲ್ಲ ಕಡೆಯಿಂದ ಬರ್ತಾರೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ಟು ಇಂಟರಾಕ್ಟ್ ಆಲ್ ಓವರ್ ಇಂಡಿಯಾದಿಂದ ಎಲ್ಲರೂ ಬರ್ತಾರೆ. ಸೊ ಅವ್ರ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಮಾಡೋದಂದ್ರೆ ನಾವು ವಿ ವಿಲ್ ಬಿ ಟಾಕಿಂಗ್ ಇನ್ ಇಂಗ್ಲಿಷ್ ಅಂತ. ಅದಕ್ಕೋಸ್ಕರ ನಂದು ಕನ್ನಡ ಸ್ವಲ್ಪ ಕೆಟ್ಟದಾಗಿಲ್ಲ, ಬಟ್ ಸ್ವಲ್ಪ ಕೆಟ್ಟದಾಗಿದೆ ಇವಾಗ. ಸೊ ಸ್ವಲ್ಪ ಇಂಗ್ಲಿಷ್ ಬರುತ್ತೆ, ಸ್ವಲ್ಪ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಫಸ್ಟ್ ಥಿಂಗ್ ಅಂದ್ರೆ ನಾನು ಇಲ್ಲಿಂದ ಐ ಡೋಂಟ್ ನೋ ಲೈಕ್ ಐ ಡೋಂಟ್ ನೋ ಎನಿ ಆಫ್ ದ ಸ್ಟೂಡೆಂಟ್ಸ್ ನೋ ಮೀ ಬಿಕಾಸ್ ಐ ಪಾಸ್ಡ್ ಔಟ್ ಫ್ರಮ್ ದಿಸ್ ಕಾಲೇಜ್. ಯಾವಾಗ ಅಂದ್ರೆ 2021 ಅಲ್ಲಿ ನಾನು ಈ ನಮ್ಮ SDM ಮಹಾವಿದ್ಯಾಲಯದಿಂದ BSc ಅಲ್ಲಿ ಪಾಸ್ ಔಟ್ ಆಗಿದ್ದು. ಸೊ ನಾನು ಪಾಸ್ ಔಟ್ ಆಗಬೇಕಾದ್ರೆ ಐ ಸೆಕ್ಯೂರ್ಡ್ 3rd ರ್ಯಾಂಕ್ ಟು ದಿ ಯೂನಿವರ್ಸಿಟಿ SDM ಕಾಲೇಜಿಂದ. ಸೊ ದೆನ್ ಇಲ್ಲಿಂದ MSc I completed in University of Mysore, MSc in General Chemistry. So research ಬಗ್ಗೆ ಹೇಳಬೇಕಂದ್ರೆ I can strongly say that my research foundation, the interest in research started in 12th standard when I decided no, I am not going to do engineering, I will do BSc. Yeah, there were many people, for example ಹೇಳಬೇಕಂದ್ರೆ ಡಾಕ್ಟರ್ ಸುರೇಶ್ ಎಸ್ ಅವರಿದ್ರು, ನಮಗೆ PUC ಅಲ್ಲಿ ಅವರು ಪಾಠ ಮಾಡ್ತಿದ್ರು. So and there were multiple people who used to take us tuitions, and also my PUC principal is also here, Dr. MH Bhatt, and all the faculties. So they used to teach us, and okay, I got inspiration from everyone. Nangastu okay, I have to be in science and I have to be more contributing. Nange, to be honest, I got Karnataka CET rank in engineering. I got RV College of Engineering, which was one of the which is one of the top college now in engineering as well. But I thought no, I'm not going to do that. Many people oppose me. No, this is you are making a wrong decision of your life. But I felt no, I was right. When I joined BSc joined there, I got my Inspire scholarship in my BSc. So that was manageable because I got a good score in PUC also. Otherwise, I joined BSc with having no knowledge of more science, with basic knowledge in science of +2. Engineering ಮಾಡಬೇಕಂತ ಎಲ್ಲರೂ ಫೋರ್ಸ್ ಮಾಡಿದ್ರು. ಸುಮಾರು ಜನ ಹೇಳಿದ್ರು you have done the wrong decision, you will repent in your life. But I can strongly say that I have not made a wrong decision, and those who have said that they might repent that okay, this guy has taken science, so he is going to do so and so. I'm not cursing anyone, sorry. Just said. But yeah, then science BSc banda, they had UGRC, which was started, and I am proud that I was one of the students who worked in that UGRC.
MH Bhatt ಅವರು ಪ್ರಿನ್ಸಿಪಾಲ್ ಆಫ್ ದಿ SDM PU ಕಾಲೇಜ್, ಅವರು ಸಹ ನಮ್ಮಿಂದ ಒಂದು ಪುಸ್ತಕವನ್ನು ತೆಗೆದುಕೊಳ್ಬೇಕಂತ ಕೇಳ್ಕೊಳ್ತೀವಿ. ಸ್ನೇಹಿತರೆ, ಈ ಕಾರ್ಯಕ್ರಮ JNCASR ಇಂದ ಸಾಧ್ಯವಾಗಿದ್ದು ಅತುಲ್ ಅರ್ವಾಲ್ ಅವರಿಂದ ಮತ್ತು ಅವರ ತಂದೆಯವರಾದ ಹರಿದಾಸ್ ಅವರಿಂದ. ಹರಿದಾಸ್ ಅವರು ಬಂದು ದಯವಿಟ್ಟು 1 ನಿಮಿಷ ನೀವು ಇಲ್ಲಿ ಬಂದು ಹೋಗಬೇಕು ಅಂತ ಹೇಳಿ ಕೇಳ್ಕೊಳ್ತಾ ಇದ್ದೀನಿ. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇವರು ಅತುಲ್ ಅವರು PhD ಸ್ಟೂಡೆಂಟ್, ಸೊ ಅವ್ರನ್ನ ನಾನು ಡಿಸ್ಟರ್ಬ್ ಮಾಡೋಂಗಿಲ್ಲ. ಹಾಗಾಗಿ ನಾನು ಎಷ್ಟು ಕ್ವಶನ್ಗಳು ಕೇಳಿದ್ರು ಸಹ ಹರಿದಾಸ್ ಅವರು ರಾತ್ರಿ 12 ಗಂಟೆಗಾಗಲಿ ಯಾವತ್ತಾಗಲಿ ಬಂದು ಎಲ್ಲ ವಿಚಾರಗಳನ್ನು ನಮಗೆ ತಿಳಿಸ್ಕೊಡ್ತಾ ಇದ್ರು. ಜೊತೆಗೆ ಕಾಲೇಜಿನ ಇಂಟ್ರಾಕ್ಷನ್ನು ಸಹ ಅವರೇ ಮಾಡಿದ್ರು. ನಮ್ಮೆಲ್ಲರ ಪರವಾಗಿ ಹರಿದಾಸ್ ಅವರಿಗೆ ಮತ್ತು ಧನ್ಯವಾದ.
Dr. Vinay Patel, Dr. Arun P, Dr. Vidya Dutani. I also request Mr. A. Jayachandran to please be present on the stage.
ಇಲ್ಲ, 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 ಇಲ್ಲ.